best things. Let's get us going on YouTube. We got us going on TikTok. My internet's about to die because it doesn't like all the streaming stuff. But again, don't worry. If it starts being choppy, it fixes itself in like 5 or 10 minutes. The internet figures out what it wants to do. Okay. Let's see this. Use Gauss's law to find the electric field inside a uniformly charged sphere of charge density rho. Very cool. So this comes from Gauss's law, right? Which says that E dot dA, integral of that, is equal to Q enclosed over epsilon naught. Oh, the lab reports are crazy? Damn. So when you have a sphere that has a uniform charge density of rho, okay? What I like to think about is as you go further and further outwards with your Gaussian surface, you're going to start enclosing more and more charge. And so there's kind of like an equation we can come up for figuring out how much charge we are actually enclosing. And one second, let me start my chat on this one. I think it's this one. There we go. All right, YouTube chat's up, and let's see if we can get TikTok chat running real quick. Sometimes it works, sometimes it doesn't. Sometimes I gotta click on it, like sign in sometimes. 2 seconds here. Go to my profile. You know I'm live. There we go. Nice. Cool. Test. And does that come through? Good night, doctor. I gotta get in 6 hours. Yeah, good night, dude. Good luck with the school stuff. Congrats on being number 1 out of 124. That's super dope.
That's dope.
Okay. Eventually my chat will work here. Who knows? What kind of PC do you have? I have a couple PCs. If you want to know my specs, I think you just do this. Specs. There you go. There's my specs. That's my main PC that I game off of and stream, and then I have a secondary PC I use to stream on TikTok. So, a little bit of both. Anyways, so, EDA. This is for a spherical Gaussian surface. This ends up being E times 4 pi r squared, because the integral of dA is the surface area of a sphere. That's 4 pi r squared. Q enclosed, this is interesting. So, Q enclosed is going to be equal to rho times the volume that is enclosed, right? Because the charge enclosed is the charge density times the volume that is there, okay? And the volume you enclose is going to be 4/3 pi r cubed, right? Okay, cool. Yeah, I do want gigabit. Yeah, exactly. 4/3 pi r cubed. Good. So then we can write this as 4/3 pi r cubed over epsilon naught. Nice. I see some pi's are going to cancel. So get rid of the pi's. Get rid of the 4's. You can get rid of one of the r's. Or r squared. All right, so now you're left with that E is equal to 1/3 r over epsilon naught. Usually I think we put like a k in here and stuff, yeah. And then sorry, there's a rho there. Yeah, sorry, my bad. There's also a rho. Yeah, rho. Cool. So this is cool. The electric field actually increases linearly then, right? With radius. This is for physics, but this is this definitely is a engineering thing as well. So then here's a cool thing. This is r hat, right? Which r hat can then also be written as r vector, right? So this is gonna be 1/3 rho over epsilon naught r vector. Yeah. Okay. So 1 over epsilon naught is not k. 1 over 4 pi epsilon naught is equal to k. So I would have to like throw another 4 pi in there. Oh yeah. Your new favorite channel. That's sick. Welcome. Yeah. Make sure like, subscribe, all that stuff. Follow. You know You'll get notifications. Okay, so that's the first part, which is done. So this is the electric field within a uniformly charged sphere of charge density rho. There's interesting things to this, right? Because once you are outside of the sphere, the electric field changes, because now you're no longer enclosing more charge as you go further out. So we should be a little careful with this. This is the electric field inside. Turns out if you want to do the electric field outside, okay, well, now that's E times 4 pi r squared is equal to Q enclosed. Q enclosed is going to be 4 pi big R, 4/3 pi big R cubed times rho, because this is the volume of the whole sphere, and then this is over epsilon naught. So yeah, the 4 pi's will cancel out again, but these will not. These are two different R's. So big R refers to what the radius of the whole thing is, and then little r is how far away you are. And the cool thing is this is literally the electric field for a point charge. So once you're outside a sphere, you can reduce that sphere you're looking at as a single point of charge. So yeah, this becomes, what is this? It's like big R cubed over little r squared, 1/3. And then it's rho over epsilon naught. And then it's the same thing, r vector. Or no, sorry, it's just r hat. Interesting. Okay, yeah. This ends up being r vector over r to the third, if you want to put it in vector form. Yeah. Magnetic fields, I totally can. So if you want to submit a question, Foster Pierce, that's the best way for me to work on questions. So right now we have a question coming up from, this was Poison Mouse, and so he sent me this screenshot. There's a website down there that makes it easy to just send screenshots. Okay, so now what I want to do is we want to figure out what the electric field is inside a uniformly charged, this one, sorry, two spheres, each of radius r, carrying a uniform volume charge density plus rho and minus rho are placed so that they partially overlap. And then call the vector from the positive center to the negative center D. Show that the field in this region of overlap is constant. Find its value. Okay. So we gotta, anytime you're dealing with vectors and stuff, you have to start drawing diagrams. It gets pretty difficult to do it without it. Let's use red and blue for like positive and negative, right? So let's have this be like the positive sphere of charge, right? And then have this be the negative sphere of charge. What times do I usually stream? Also, if you go to that website there, actualdiscord.com/submit, there is a calendar. So I'll show you real quick. Right here on this website, you go here to streaming schedule. That will pull up all the times that we stream and all the times our friends stream. So Zach is going to be doing a math stream tomorrow morning if you want to go check out an earlier stream, and then I'll be in the evening. So yeah. I don't need the picture. I can create the picture. I already know what's happening. Yeah. Oh, they did give us a figure. Yeah, where did you share it? Where did you share the figure? Oh, here. Sure. I don't know, but this figure is kind of garbage. I know what you're talking about. Mouse, this is the figure. I don't know, but it's not even like shaded or anything. It's a trash ass figure, dude. What? Okay. I'm gonna do it this way.
That is one big pile of shit.
I do everything, Hostels. It's just I happen to be doing physics because that's what's been submitted today. But I do anything math or science related, middle school up through college. So chemistry, stats. I do a lot of calculus. All right. So from the positive center to the negative center, that's a vector D. Let's draw that out. Let's make this kind of like bigger. What color? Let's make this green. Okay. So this is going to be vector D. So this points to from the positive center to the negative center. Oh, cool. Yeah, I can help with electrical engineering for sure. All right, let's talk about what the electric field is due to the red one. Okay. And then let's consider that this right here is our origin. Okay. So I know that the electric field is equal to, in this case, let's restrict ourselves to inside the red sphere. It's 1/3 rho over epsilon naught, and then this is r vector. Okay. Key thing about r vector is r vector in this case, let's say like r plus vector, is the vector that points away from here to some position r. I want to describe this position from the origin instead. So what we could say is, like, for instance, this right here is r plus vector, okay? Whereas when I'm measuring things, right, I'm measuring things from the origin, and so this is really what, and let's make it a different color. Let's make it blue. I like this one. Yeah. This is really what r vector is. Because eventually, at the end of the day, I want the net electric field as a function of r vector, so measured from the origin. And that's going to need to be the electric field contribution from the positive one plus the electric field contribution from the negative one. The negative sphere, okay? So, cool. We got our hat there, right? Okay, let's figure out what the electric field would be from the negative one, right? So this one's the positive. So E negative is going to be negative 1/3 rho over epsilon naught, and then we're going to say this is like r vector negative, okay? So that points away from the center of this one, okay? And let's say, for instance, that points to here, okay? So let's call that like r negative. Explain Rolle's theorem. I have a good video on Rolle's theorem. If you go check out my TikTok hike, I have so many videos. I have a really good one on Rolle's theorem. It's on my main page. I can show you real quick. Where's my TikTok? TikTok. Boom. I think I did this. Rolle's theorem. Is that the mean value theorem one? Yeah, here we go. Understanding the mean value theorem and Rolle's theorem. Yeah, go watch this video. It's right down here. It's got fun stuff in it. So, yeah, if you're on TikTok, go to my profile page, leave me a follow, please. And then I have a video down here, literally on Rolle's theorem. And if it doesn't make sense, like, come back to the stream and ask me a question about it, and I'll help you. Rolle's theorem is not MVT. It's a special case of MVT, is what it is. It's when they're both 0, I think. Yeah, it's when like y1 and y2 are both 0. Yeah. You call it the Lagrange theorem. Oh, okay. All right, so here we got E negative. Okay. So let's try to write this out. Right, E plus plus E minus. So that's going to be equal this. Right. Minus this, okay, which is going to be equal to 1/3 rho over epsilon naught, and then this is going to be r plus vector minus r minus vector. I can definitely do linear algebra as well. Yeah, definitely can. Okay. Making sense so far? And then where is... No, not that. Ooh. Okay, so now let's come up with some expression for r plus vector and r minus vector. So let's look at our diagram here. So this is where this is fucking rad, dude. Because r plus vector here minus r minus vector, right? So we do this one minus this one. And so this one is pointing this way. So negative r minus vector would point in the opposite direction this way. Do you notice how, like, this minus this, which is this, really plus this? Here, this is the better way to write it, right? So I can say, like, r plus vector plus the negative r minus vector. So this plus this is literally d. it's the same vector that connects the center of the positive one to the negative one. So I can replace this with 1/3 rho over epsilon naught, and then this is just going to be vector D. And so now you're done. And you can see that the electric field in the overlap region is constant. It doesn't depend on R at all. Yeah. The other way I could have written this, so I did this in this way and this way, is if we're measuring it, I could have also written that, let's say this is, you have to like point to this. This is like R0 plus. Then you would say that R vector is equal to R0 plus R plus vector. And so solving for R plus vector, you get that R plus vector is equal to R vector minus R0 plus vector. So this is like what points to the origin of the red one. And then this one would be R minus R0 minus vector. And so you get the same thing. You'd say R minus is equal to R vector minus R0 minus vector. Okay? And so if you were to replace these in for this to have your thing as a function of R, you would still see that this cancels. And you end up getting minus R0 vector, R0 plus vector, plus R0 minus vector, which is R0 vector minus R0 plus vector. And this right here is also vector D, right? If I do this minus this, I get this. Because in the same way, if I do this vector plus this vector, I get this vector, right? R0 plus D also gets you R0 minus. So R0 plus minus, so R0 minus, sorry, vector minus R0 plus vector is equal to D. Same thing. Cool. Does that make sense to you, Poisoned? This is a really cool question. I love this one. Also because it deals a lot with vectors. Very visual and stuff. Yeah, nice, cool, awesome, sick, great. Poison says we should do more of these like a study group. I mean, this kind of is a study group, right? But you guys are just coming up with the questions. Yeah, Don used to do this too. Don would like run through a physics course. And those are really cool. He's basically teaching at that point. The only issue is like, everybody has to be kind of on the same page to like go through it. Don retired. Yeah, no, he's still on. Don's definitely still on. Yeah. Pretty. Yeah. No. He stopped streaming. I don't think so. Genuine question. Do you consider this fun? Yeah, I do. I think this is tons of fun. I don't know, it's like puzzles. Puzzles are fun. Oh, he's not doing a mechanics and electro, yeah. You should prove the Collatz conjecture. No, not doing it today. Anyways, okay, cool. Good question, Poisoned. So here on... Oh, not that. Not that. Where's the Q? Here on the Q, we're going to mark Poisons as being done. And so that should update. There you go. Now we got Nicola's coming up next. Yeah, if I proved the Collatz conjecture, I probably would make some millions. Okay, nice. Nicola, let's see. Which one did you need help with again? I think it was... Oh, man. Here we go. Positrons and masses. Okay, here are the Q. So again, yeah, if you're just joining us from YouTube, Twitch, whatever, feel free, please. We have a website if you want to submit screenshots for questions. Just put in some sort of username. I don't care what it is. And then drag and drop a screenshot, upload it. We'll go through it. You can always see what the queue is so far. Nicola's got a couple cool questions. If anyone submits one like in between, I'll bump up and do yours after Nicola's. But if no one else is answering questions, I'll just run through all of Nicola's. Yeah. Well, oh, nice. Night, poisoned. Yeah. Yeah, if I stream earlier, we'll see. I'm already streaming 5 times a week. Adding more earlier times would start to maybe cut into, like, my ability to pay rent. But Zach is around. We love Zach. Yeah, shout out to Zach, by the way. Can I shout? Did I shout out Zach yet? I don't think I did. I fucked up. Yeah, shout out to Zach. Zach's great. He streams earlier. It's just an extra 8 cents on YouTube. Okay. All right, let's see. Nicola, you around? I'll hit you up in the chat. Good night and thanks. Yeah, you're welcome, dude. Yes, here. Okay, Nicola. Let's do this one. You tell me if you don't want to do this one, but I'm going to assume you want me to do this one. So it says a positron has this mass, this charge. Cool. So a positron is basically an electron that has positive charge. So opposite charge of that. It moves on the electrostatic influence of an ionized uranium nucleus, which is assumed fixed in place, infinitely massive for our purposes, and has these charges. So, cool. I don't know. Oh, the uranium has a +8 charge on it. Suppose when the positron is at this distance from the nucleus, it is moving away with that speed. What is the speed when it's this? So this is conservation of energy, right? So the kinetic plus the electric potential energy all has to be the same, right? So we can always do E before. So actually, let me call. I always like different like situations. Let me call this like EA, and then we can have EB. Okay. So energy before is going to be equal to 1/2 mv0 squared plus the potential electric potential energy, which is going to be equal to QV, right? And then in EB, we're going to have 1/2 m. Okay, and they talk about 1 and 2, not 0 and 1. Okay, fine. Okay, so mv1 squared, and this will be 1/2 mv2 squared plus Q. And let me use a potential. I'm going to say this. I'm going to say potential 1. I'm going to call this Q potential 2. And I have to remember the signs on this. Because you have to be careful about whether energy is increasing or decreasing. If you have a positive thing and a positive potential, the further it moves away, the less energy there is. So getting the signs right is tricky here. I think that was something that kind of messed us up a couple days ago when I did... Which question was it? This one. Yeah. This was a mastering physics question, which talked about a proton being in a potential, and then what's the speed before and after. And we got this one right eventually, but you have to be very careful about what the signs are. And like a lot of things here in physics, I don't recommend people just memorize hard and fast rules about pluses and minuses. You want to use your intuition and understand how physics works, like, you know, is the potential going up or down, and then apply whatever positive or minus sign you need that makes sense. What's the waiting time? Oh, probably like 5 or 10 minutes right now. Yeah. Because this is Nicola's question, but if you have another one, I'll do yours like after hers, and then I'll go back to hers. So probably like 5 or 10 minutes at this point. I should put like an estimated queue time, shouldn't I? Okay. So, key thing here is that potential in an area, right? Is going to be equal to the sum of whatever like point charges are like causing that to happen. So in this case, you have a uranium nucleus. So you have this is uranium, which has a +8 charge on it, +8 E. And that's creating a potential field, which is technically a scalar. It's a number. It doesn't technically have a direction. But it goes outwards and it decreases as like 1/r. Okay? I can try to translate it, Nicholas. Yeah. You can just submit it. Submit it and I'll tell you whether I can do it real quick or not. So if I want to figure out the potential due to the uranium nucleus, right? This is going to equal to K times 8E all over R. So R is like the distance you are away from this, okay? Nice. All right. And we're talking about another positron. Great. Yeah, okay, cool. All right. So I can now replace this phi 1. So this is phi 1 is going to be K this, which is the charge of your uranium thing that's creating potential, over R1. And then you're going to multiply that by the charge that's in the field. So for instance, this right here, Nicola, this is the phi 1 being produced. And then you have the positron. So this is the positron, which has a charge Q. And because it's in the presence of this, it's going to have energy, right? And what we say is that if it were to get closer to it, it's going to increase in its potential energy. You can kind of think of it as like the reverse of gravity, right? When things fall down, they have less gravitational potential energy. When things fall into, like, moving against where you want to go, you increase your potential energy. If you move away from where you want to go, you're technically decreasing potential energy. That's how I like to think of it in like the big picture, because it gets really confusing, potential and like your positive, negative, like what's going on. Okay, so we have some stuff here, right? We got some values, and they just want to know V2. Sweet. Okay, so 1/2. We want to know this. Okay, so I remember doing this. So this is 1/2 m v1 squared plus q phi 1, and then we're gonna have this energy has to equal this energy. So we're gonna say minus q phi 2, right? Is equal to 1/2 m v2 squared. And then I think what I did is I multiplied everything by 2 is I think what I did. So I did m v1 squared plus 2q m v2 squared. So then we divide by m. You struggle graphing and trig? Oh, well, hey, submit a question there, if you want, on like one of your trig things, and I'll go over it. So if we divide everything here by m now, Nicola, this goes over m, this all goes over m. So this is now this. This is over m, and then we can square root both sides. So I get v2 is equal to the square root of v1 squared plus 2q phi 1 minus phi 2 all over m. And let's see if this makes sense. So if my potential goes down, my velocity should go up, right? In order for, yeah, I do biochem for sure. Can you see Henry's question? If you ever want to see any of the questions, go to, if you go to like the Q website, so if you go to here and you hit on live Q, you can then click on Henry here and you can see what his question is, and it'll pull up. He took a very, very large image, but yeah, Henry, that's your question. Just the website has it. Okay, but let me think about this. So let's say if the potential is negative, so that means phi 2 minus phi 1 is negative. Then which that means that phi 1 minus phi 2 is positive. Then the velocity should go up, and that does make sense here, right? If this is positive and this adds a positive thing, v2 will go up. So our signs are correct. I'm cool with the signs now. You gotta be careful with the signs. Okay, so now you just plug some numbers in. So what's that? V1 is 3 times 10 to the 6. So 3 times 10 to the 6 squared plus 2. And this is going to be the charge of the positron, which is just E. So I'm going to say 2E. And now I got to figure this out. This is kind of annoying. So if phi 1 is equal to this, phi 2 is equal to K80 over R2. So phi 1 minus phi 2. Yes. Yeah. What do? I teach physics at UCLA. I also just help people. I have like a nonprofit. Okay, so this is 8KE, right? If I do this one minus this one. And then that's going to be 1 over R1 minus 1 over R2, right? That's what this is. So this whole thing comes into here. This isn't electromagnetic fields. This is just I don't even think this is electric fields. I mean, there are electric fields being created, but it's just conservation of energy with electrostatics. Okay, so then this is 8KE, 1 over R1 minus 1 over R2. Okay, and then this is all over the mass of our positron. Okay. Kind of a mess. We're going to get there, though. So 2E and 8E is going to be 16E squared. So 16E squared K. Oh, general relativity? Oh, I don't know about GR. No. No. I don't really want to do GR, dude. Don't give me... I don't like relativity, honestly, in general. Relativity is such a mindfuck. This topic is E and M, or it's really electrostatics is what we're doing. If you want to see the question, the website down there, if you hit on the live queue, you can click on the question that's being answered right now. If you want to like read what's happening up here. God bless. Good luck. Thanks, man. Appreciate you. We got our K in there, right? Okay, cool. Oh, so all I need is R. So R1 is 1 times 10 to the minus 10, and R2 is 2 times 10 to the minus 10. Cool. So 1 times 10 to the minus 10 is equal to R1. 2 times 10 to the minus 10 is equal to R2. If I was being a clever man, I would write those in, but I don't care. I'm going to pull up the calculator now. Donde está calculadora? There we go. Cool. All right. We got to do this on the calculator. 3e to the 6 squared plus 16. And then little e here is the charge of an electron, but the absolute value of that. So that's 1.6 times 10 to the negative 19. And then that's squared. And then we multiply by k. K is 9e to the 9. And then we're going to multiply by 1 divided by 1e to the negative 10 minus 1 over 2e to the negative 10. Cool. I think that's okay. Great. And then we need to divide by m. And the mass is 9 times 10 to the minus 31. So divided by 9.11 e to the minus 31. That's a big fucking number. I don't like that. I guess the minus 10s are kind of fucking us, aren't they? Yes, you have to go to McCone's office hours. Bless you. Yes, I will. I'll be on past 5. Probably on until at least 6. So, yeah. You're all good. Let me just get a final answer here for you. I don't like this. Like, 10 to the 21? Something's wrong with my numbers. I did something wrong in the calculator. Okay, not that. Where's my calculator? Bum, 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 bum. What is A-Rock? I don't know what A-Rock is. Sorry, I want to see why this is wrong. What do we do? So we did... Oh, average rate of change? Yeah, totally can, yeah. 3e to the 6 squared, cool. Plus 16. Right? 16. Oh, e squared. No, I did do that, right? Wait, what? How did that become exactly 9e to the minus 12? One sec. I feel like this is wrong. Oh, you know what I did? I needed to divide this by m. Sorry, that's why it was. Okay, watch this. Okay, it's this. I made a little calculator boo-boo. It's this divided by the mass. Yeah. I see why I was getting the same number. Because I just did this plus this and then all divided by this. Not going to work. You have to do this. This is a very, very small number. And so this is also a very small number. So if you add a regular number to a small number, it doesn't change it very much. That's why I was looking. I was like, wait, why is it the same value? Okay, sorry. Then what's the mass of this electron? 9.11 times 10 to the minus... Okay, 9.11 e to the minus 31. Okay, there we go. Much better. Good. Okay, then we square root this. Okay, cool. And that's the final answer we get. Don't need all that. Not this. Okay, cool. So looks like this many meters per second. Which, what is that? That's 5.4 times 10 to the 6. Which I think should make sense because you're losing potential, right? Good. Yeah. So we had a lot of velocity. We had a little bit of velocity, sorry. A lot of potential. We started moving away from our potential source. And so losing potential energy should gain kinetic energy. Yes. Okay, so I think this is correct. Let me see what ChatGPT said. I always like to check chat. ChatGPT is a great way to like check your work and see what you're doing. All right, let's see. Oop. All right, got it. Cool. So it also did energy conservation. Yup. Also, this they didn't. I simplified mine a little bit differently. Oh, cool. 5.4 times 10 to the 6. We got the same answer. Love that. I call that success. Nice job, everybody. So, let me download this for Nicola. What question was this? Let me see what this was. This was problem 3, part A. There's technically a part C, but I'll wait for her to come back to do that one. She has to go to office hours for the actual professor who's teaching this class. So, okay, cool. All right, let's see. What's next on the queue? So, Henry, I'll do your question next because we just did Nicola's. So, mark that one is done. So, Henry's question, which looks like a zipper question, maybe? This is cool. Oh, this is like a related rates question, Henry. Someone asked me, is TI better than Casio? Is Casio better than TI? Why do the two calculators produce different what? They should give you the same answers without anything. I personally like the TI better, just because I'm used to it. The Casio is a lot cheaper. I will say the TI is pretty cost prohibitive. And I have physical ones as well. Like, I don't just have the emulators. And this thing is like $140, I'm pretty sure. Like, let's see, TI 84. Streaking hard. What's up, Femvox? 15. Thank you, Fem. Yeah, wait, what was this? Yeah, $135. Oh, I guess, well, this is a really old one. This is the TI 84 Plus from like the 2010s. I guess Target has it on sale. But yeah, $114 was $120. This is ridiculous. Because, I don't know, we used... This is so old. This tech is so old. I mean, yeah, it's a color screen now, but... You know, I don't know. It's Texas Instruments, don't ask me why. They have like some stranglehold on being the official calculator for tests. What's up, Evenion? Been a while? Yeah, nice. Lots has changed. We're a YouTube partner now. I finally made partner on YouTube. Took me 3 fucking years. But yeah, the TI-84 is solid. I prefer the TI-89 Fembox. That's my bread and butter. I love the 89 because it has symbolic manipulation. But it's not allowed on a lot of exams. Okay, at instance below, cars A and B are traveling at velocities of 40 meters per second and 30 meters per second. If A is increasing at a speed of this, so that's an acceleration, whereas the speed of B is decreasing at that, determine the velocity and acceleration of B with respect to A, given that the radius of curvature of B is PB. Oh, wow. Okay. This is kind of a tricky question. Yeah, I don't like the N-Spire. The N-Spire is like, to me, is... The 89 is at least the same form factor as the 84. Just more powerful. The 89, I don't know where all the keys are. It confuses me. Okay. So, let me, like, kind of draw a graph, I guess, of what's happening. So, I guess A is the blue car. You think you have to use polar coordinates? We might have to. Let's see. So, VA naught is equal to 40 meters per second. And this is in the y-hat direction. I'm going to put things in Cartesian first, and then I'll probably just put it in polar. You're right. But then dv a naught dt is equal to 4 meters per second squared, and that acceleration is also in the y-hat direction. Yeah. Okay. The weird thing is B is moving. So B also has centripetal acceleration. But okay, so B is moving in an arc. So let's kind of draw the arc that's happening here. So this right here is B, which the velocity of B, or VB naught, and sorry, these are vectors. I should have written, these are vectors, right? Yeah, I'm going to try and do it graphically with vectors. So VB naught is equal to is 30. And that's in the phi hat direction, right? Like its velocity is always pointing tangentially to your curvature, right? Which I think the way to describe is isn't it R omega? Right? So VB naught is equal to R omega. This is like the other way to write this, right? Or maybe NT coordinates. Radius of curvature. Yeah, no, cool. So the radius of curvature. So this thing is eventually going around in a circle, right? The radius of curvature refers to this. Let's get a different color. It came right out of the dynamics text, yeah. So this is radius of curvature. This is r. So I know a couple things, right? I know that tangential speed, v, is always equal to r omega. And then I believe this is in the... I'm going to say theta hat direction, right? Because it always points where the angle is going. I think this is right. Okay. And then the acceleration, so dvb naught dt, that's equal to -3 meters per second squared in the phi hat direction, right? We following along so far? Okay. Determine the velocity and acceleration of B with respect to A. Oh, okay. So then, with respect to A, so I want to know VB minus VA? Is that what this is? You're like VB relative, right? I think that's what we're saying, right? So like, VB relative is equal to VB in like my generalized coordinates minus VA. Yeah? Which, I mean, this is easy because VA is 40 y hat. But then this is interesting. So I think we need to convert from... I think we need to convert this from polar to Cartesian. So, yeah. Okay, so x hat is equal to r cosine theta. But then I need, like, where it is. Or no, I shouldn't say x hat. I should say x is equal to r cosine theta. Y is equal to r sine theta. That's the general polar parameterization, yeah? Oh, and they do give us an angle. Oh, very cool. Oh, they give us the angle here. Oh, I can convert this right away. You're totally right. Yep. So I just need to break this up. Okay. I didn't notice they already gave us the 30 degrees. That's actually really nice, right? Yeah. Because so this is pointing in the y hat direction. So I just want to break this up into components, right? So if this is 30 degrees, that tells me what? This is now going to be 60 degrees? Okay. So yeah, it's not that complicated. So VB at the instant of 30 degrees from the vertical is going to be equal to negative 30 cosine of 60 degrees in the x hat direction plus 30 sine of 60 degrees in the y hat direction, right? So cosine of 60 ends up equaling negative, it's positive 1/2, but then there's a minus here, so this is going to be negative 15 x hat. Right? Plus 15 square root of 2 y hat. Yeah? I think so. Okay. So then VB relative is just going to equal negative 15 x hat plus 15 square root of 2 y hat subtracted from 40 y hat. And then we'll get to acceleration. Exactly, right? Cool. So, I don't know. Sorry, do they want a value for it? I guess we could get a magnitude, maybe. Yeah. I mean, this is correct, right? This is the full form of it. So it's really negative 15 x hat, and then plus 15 square root of 2 minus 40 y hat. Yep. Square root of 3 over 2. Thank you. Yeah, I knew I had my 2's wrong somewhere. You're so right. Jack-o'-lantern. Good catch, bro. You're paying attention. I love that. Yeah. I had to divide by 2, right? I had the wrong thing in the square root. Square root of 2 over 2 is 45 degrees, obviously, right? Okay. Your 2 should look like a 2, not a Z. No, my Z's have this. I put lines through my Z's. Can you do V squared over R for acceleration? I think you can. Yeah, totally. Yeah, because that's centripetal acceleration. Okay, whatever. That's VB. So let's do the accelerations, right? Yes. So the acceleration of the thing moving straight, right? That's 4 in the y hat direction. But in order to do the acceleration for this thing, I can definitely do diffie q. Yeah. Give me a screenshot. I tell people. There's a website right there. actualdiscord.com/submit. Be like all the other cool students and just drop in a screenshot of some sample homework question, practice test question, previous test question. I don't care what it is. Something you want me to go through, I'll go through it and I'll teach it to you, and everyone on the stream here will learn. We love it. You just have to help me. Help me help you. Because if I just go hunting down screenshots, it'll just take forever. So you give me a screenshot. I'll do it. Today I've been streaming for an hour so far. I will go in at least another 2. Okay, so if something is moving around in a circle, it experiences a centripetal acceleration, okay? Directly towards the center of the rotation. The interesting thing here... Oh, they did give us... Okay, cool. What's funny here, though, is I'm going to have to figure out what R hat is. They did give us R. I think I have to assume it's happening... Oh, man. I think I kind of see how this is going to work. This is weird. It's weird. Wait, if that's going straight and that's going at 30 degrees, then aren't they kind of mismatched from each other? No? Yeah, this is an interesting like geometry question. You have normal and tangential acceleration? Tough question. That's why it's only a 1 asterisk. So you're right. I do have tangential acceleration. Correct. My issue here, Hike, is that my normal acceleration points towards the it has components to it, right? So this thing right here has acceleration pointing in this direction. The question is, how do I break this up into X and Y components? I think that's the issue. Because, yeah, sure. So, acceleration of B, I agree, is going to be... Yes. So there's going to be... but then what's the direction, Fembox? Right? So it's going to be acceleration at B tangential plus acceleration at B perp, normal, I guess, right? Sure. And so that's equal to... The acceleration of B is -3. Okay. So that's -3. That's the tangential. And then the direction of that is the same thing here we had, right? So that's minus 3. So that's going to be negative 1/2, right? Negative 1/2 x hat. And then that's going to be plus square root of 3 over 2 y hat, right? And then you have the perpendicular acceleration, which needs to be equal. Oh, I see, because it's normal.
Good job.
Yeah, you're right. You're right. Yeah. I'm sorry. I had a brain fart there for a second. Yes, and then it's plus v squared over r in the minus r hat direction. Okay. V squared over r. So the velocity is 30, and r is 200. Yeah. Good. Okay, cool. So this is 30 squared over 200. And then let's talk about what the minus r hat direction is. Right. Okay, cool. I got you. So, right. Let me get colors. So if this right here is 30 degrees, and then centripetal acceleration always points perpendicular, normal, right, to it, okay? And then I think shit, I think I already baked in the minus, right? I think I already baked in the minus, right? Yeah, I did, because I said minus r hat. So we got to figure out what r hat is. So that's this direction. Okay, this is cool, because this makes a triangle, right? Uh-huh. Look at this. This is also 90, right? This is so cool. No. Yeah, there we go. That's what I want. Okay. This is 60. This is 90. So this is 30 degrees. Okay, cool. So now the y component is sine of 30. And then the x component of the acceleration, normal, the perpendicular acceleration, is cosine of 30 degrees. Oh, okay, cool. So, let me just write that up here. Yes. Very cool. So, r hat is equal to r, or no, it's just equal, we don't need the r on it anymore, right? Yeah. I just need cosine of 30 degrees x hat plus sine of 30 degrees y hat. That's r hat. And then I already put the minus r hat in there because it points inwards. Cosine of 30 is square root of 3 over 2. And then this is plus 1/2 y hat. Okay, nice. Okay, we're almost there. We're so close. So we have that. And then I have minus square root of 3 over 2 x hat minus 1/2 y hat. Which, yes, is below the x-axis. And it's also to the left of the y-axis, right? That makes sense. This is in quadrant 3. I need it to be. So I'm glad it's in quadrant 3. Okay, so what is this? 3/2 minus... What is that? 900 square root of 3 over 400? X hat? Minus 3 square root of 3 over 2. Plus 900 over 400. Right? Y hat? I think that's right. I see. And then that's just the acceleration of B. And then we have to do B minus A. Okay, this is kind of a long ass fucking question.
That's dope.
It's not that dope. I will cancel the hundreds. Yes, let's do it. Cancel, 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 cancel. Cancel, 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 cancel. Okay. Oh, okay, so 3/2 minus 9/4, whatever. What is that? Negative 3/2, negative 3/4? No, wait. Yeah. Negative 3/4. Right? And then minus, this is not anything nice. 9 plus 6. Square root of 3 over 4. Y hat. Rigorous. Yeah. Okay, cool. So then this is AB. So then AB relative is equal to AB minus acceleration of A. Acceleration of A we said was 4y hat. So that equals all this. Minus 4y hat. So that's 16 over 4. So final thing we get is negative 3/4 x hat minus 7 plus 6 square root of 3 over 4 y hat. Is that right? Minus 16 over 4. No, sorry. Minus 25. I'm treating this all as like one big thing, right? Yeah, the 7's negative. Well, wait. We put this all together, right? This was the whole thing. There's a minus sign on it. And then we subtracted another 4. So this becomes plus 16 over 4. So this should be 25 over 4, right? I think. $25. Okay, cool. All right. Let's get out the calculator. I want to see what we get here. Because I can just plug this in the chat and just see what they say for numbers. So that's going to be 25 plus 6 root 3 all over 4. So minus 8.84. Or 8.5, I guess. And then this is negative 0.75 x hat, right? Ooh, you didn't get the same x. Uh-oh. What'd I do wrong? Oh, I think I know what I did wrong here. Dude, what? I forgot the square root of 3. I did 3/2 minus 9/4. I forgot about the square root of 3. Oh, that's so sad. Oh, I'm so sorry. No, you didn't do anything wrong. I fucked up.
Oh, no.
No, it's so sad, dude. God damn it.
No.
Sorry, it's 3/2 minus 9/4 square root of 3. So it's really 6 minus 9 root 3 over 4. Yeah, okay, there we go. Yeah. Femvox says you got the same answer, so I'm kind of tempted to say it's correct. How could you? There are children starving. They really are, dude. Just leaving these crumbs, dude, on the table, dog. All right, 6 minus 9 root 3 all over 4. Let's see what that gets in the calculator. 6 minus 9 root 3 all over 4. Negative 2.4, I would say. So I think that's it, Henry. Nice problem. Yeah, fun. Dynamics. Okay, let's see if that's the correct answer. Let's pull in some ChatGPT. I definitely can, Jose. Yeah, Jose, if you want to submit a screenshot to the website there, you see where it says actualdiscord.com/submit? If you submit a screenshot of your homework question, I'll go over it on the stream here, live, like right now. I did do the velocity, yeah. Yeah. So this was... Here, let me kill the calculator, sorry. This was my acceleration. And I think this was my velocity. Yeah. I got minus 15 x hat plus 15 root 3 minus 40. Sounds about right. All right, let's see. Okay, ChatGPT finished. Let's pull it up. Where is it? Okay, cool. So let's see. Acceleration. I think we're the same, yeah? That looks pretty similar. 2.39, yeah, minus 8.848, whatever, I'm rounding. Okay. And then... Oh, this is what they got for their velocity. Okay, I think we're good too. Nice. Yeah, look, that's... I'm assuming this is 15 root 3 minus 40. Sounds about right. Oh, here, let me just check it real quick. 15 square root of 3 minus 40. Negative 14. Okay, nice. We're good. I'll take it. Beautiful. Fun question there, Henry.
Well done.
GG, yo. Thanks, Jack Lantern. You helped me out there, dude. I almost had this. I had the sine of 60 degrees being square root of 2 over 2. Yeah, nice, Henry. Henry, if you want this file, just join our Discord. Tell me what your username is, and I'll send you the screenshot. Oh, you can't find it? Oh, it's right here. Wait, one sec. You can't find what? You can't find the website? The website's just this. It's just actualdiscord.com. Just literally type in www.actualdiscord.com. It'll automatically go to the submit part. How do I program my brain to enjoy this instead of Warzone? I don't know. You want like some more noises? Are those cool?
Surprise, motherfucker.
Here, more sounds. I can hit more things on the soundboard. I say, Jude, yeah, math is never going to be as fun as Warzone. I hate when people try to turn math into something that it's not, you know? It's the same thing when they try to, like, make vegan steaks or, like, vegan burgers. Like, vegan bacon. I'm like, no, it's not bacon. Like, it's okay. Math, to me, can be fun, but it's a different type of fun. So, and sometimes math is very tedious. Sometimes it sucks. And that's okay. That's all part of math. But I think what's important is to maybe see the big picture of that doing this is the same thing as grinding. The same way that, man, dude, playing shipment 24/7 on Warzone is not very fun, right? It's mind-numbing. But sometimes you just gotta grind camos and you gotta grind skins and whatever, like unlocks. Math can be like that sometimes. You're just grinding at different problems, so you're building up, like, your skill set, and then that enables you to, like, I don't know, get the gold skinned M60 or something. But in this case, it's you can do more fun stuff in math, or you can do physics, or you can go get a job because you've learned how to problem solve, and then that job will pay you lots of money, and then you can go buy a 5090 or a PS7, whatever's coming out, dude. So maybe see the I think seeing the long-term benefits of stuff kind of helps. Yeah, dopamine. Oh, you okay? Cool. I can call y hat as EY and X hat as E hat. Yeah. I've seen that before too. That's totally legal. Here, let me pull this in for Henry real quick. Did we do this one? Oh, this is you. Hike. 1 sec. Sorry, let me get to my... Hayuka, right? Is that your name? Hayuka? I think I helped you on another thing at some point. Femfox says, I was looking at an online bio course and they did have some kind of software that could graph proteins in 3D, but I don't remember what it was. Yeah, they do have some dope visualizations. And I mean, that's not to say that doing these problems can be more visually stimulating. I think that's what I do with my YouTube shorts and stuff. I try to visualize things a little bit more fun. Put some memes, put some humor, some, you know, soundboard effects. But at the end of the day, like, math is going to suck sometimes. And so you just got to embrace the suck. The suck is what makes it worth it. Why don't you become a teacher or tutor? I am both there, Schleb. I do tutor and I do teach. I also stream. I do all these things. The streams are free. The tutoring and teaching is not. If you want me to tutor or stream... if you want me to tutor or teach, it costs money. This is free. A hard math question is like an annoying, really difficult boss you're stuck on. It feels so rewarding when you get it done, even though it kind of sucks while you're doing it. Exactly. D-Hammer, you nailed the hammer on the head. You nailed it. You nailed it on the head. You lived up to your name, bro. Yes. ChemSketch. Yeah, ChemSketch is cool. You love my content. Thanks, Keek. I appreciate that, King Coziness. That's really nice of you, dude. What is S-plane? If you have a screenshot of what it is, King of Coziness, I can maybe look at it and kind of understand it. Math problems are the final boss. Yeah, they really are. That is true. And yeah, I am also a creator, I guess, or influencer, whatever you want to call it these days. I'm going to TwitchCon this weekend, so if you want to come say hi at TwitchCon, I will be there. All right, let's see. Henry, Henry has some more questions. Love all these questions, Henry. Yeah, let's go to what the queue is, because I don't think Nicola's back yet. Okay. Let me do Jose's, because Jose is new. So I do tend to get... I will, like, do at least one of yours, and then I will... just hang around. I'll be streaming for the next 2 hours. Let's see what Jose's question is. Ooh, volumes of revolutions. Here, we'll go to Mathland. Yeah, here we go. This is it. So, yes, I think I did. We're working on. If you go to our main website here, submit your screenshot, and you click here on the live queue, you can see all the questions that have been asked, and you can click on this and see a screenshot of what they submitted. So, we did yours, Henry. I did number 4 for you, so let me remove that one real quick. Did number 4. But now we're gonna help out Jose. This is Jose's question. Okay. All right. The volume of the solid obtained by rotating the region about the given curves is specified on the line. What is the volume? Great. Let's graph this. X is equal to... Wait. Oh, you have 2 y coordinates. Okay. Y is equal to 8 sine x, and y is equal to 8 cosine of x. And we're going from 0 to pi over 4. So I'm going to try to, like, figure out what the endpoints for this are, right? So... 8 sine of 0 is just 0. And 8 cosine of 0 is 1. So here, let's call this one like the green one. I'm going to call that like y2. I'm going to call the red one here. We're going to go Christmas colors. We'll call this y1. So this is where it does help, guys, in pre-calc to remember how to graph sinusoidals, because you need to do it in calculus. I know, it sucks, but so sine starts here, right? And we know does this, whereas cosine starts at the max amplitude and then does this. Okay. So in this case, and we're only going to 0 to pi over 4. Cool. So pi over 4 is only 45 degrees, right? So we're only going to do 1/8 of a cycle, right? 2 pi would be a whole cycle. So starting at 0, sine of 0 is 0. And then sine of pi over 4 is equal to square root of 2 over 2. So multiplying that by 8, you end up getting 4 square root of 2. So I know this is going to kind of go like, I guess this, right? It doesn't do the top. Yeah. So we're going to get to here. So this is going to be at pi over 4. And that's going to be also located at 4 square root of 2. Okay. And then kind of the same thing with cosine. Cosine is going to start up at 8. And then it's going to come down. And it's also going to meet at pi over 4 for x. And at 4 square root of 2 for that. Okay, and then we are revolving this. Ooh, we are revolving this around y equals -1. So this right here is the thing that we're like spinning around, okay? And then this right here is like the cross-sectional area. So what this ends up looking like, it's kind of funny. It's going to end up looking like a bunch of these, like a bunch of like, I want to say like, it looks like a bunt cake, probably. It's probably going to look something like this, right? Looks like a bunt cake. It's not a torus, though, because this is flat. Right? If this was like this, then yes, I would agree it's a torus. But you're only getting the bottom half. So, like, this is this part. So, yeah, it's like a bunt cake. Anyone know what a fucking bunt cake is? No? Okay, I'll look it up one second. Yeah, it looks like this. Yeah, there we go. We're gonna take this image and just pop it in here. But it's a bunt cake on its side, if that makes any sense. It's half a torus, yeah. You never heard of a bunt cake? Yeah, this is a bunt cake. So it is like a torus, but okay, it's gonna be rotated this way. There we go. So that's kind of the visualization of what happens, because this area here is gonna be a hole, right? Because you're only taking this, and yeah, it looks yummy, right? Okay, fuck. All right. All right. I want to do washers. I hate cylindrical shells. Fuck cylindrical shells. I'm doing washers. I think I can, right? I think I can do washers, yeah? Not gonna get mad at me, right? Okay. All right, so the method for washers. So if you're revolving around y equals, then you need to step forward in your washers in terms of dx. Okay? And that's gonna go from, all right, so the first thing you do is you figure out, is it dx or dy? All right, when you're doing washers, whatever your axis of rotation is the opposite. So if I'm rotating around, well, sorry, it's the same. I'm rotating around an x thing. It's y equals, but it is parallel to the x-axis, so this is going to be dx. Because we're going to be putting in a bunch of, like, these circles as we build them. And x is going from 0 to pi over 4. And then this is going to be pi on the outside, and then this is r. I think, like, I call it like r top squared, r outer squared minus r inner squared. Yeah. And then that's it, right? So the cool thing here is that r outer is going to be this green curve, right? This is always the outer radius of what we're looking at. And so describing that would be the y coordinate of this curve. So r outer is equal to the y coordinate of this, which is 8 cosine of x. But also you have to add an additional 1 because the axis of rotation is 1 below where y equals 0 gets measured from. So this is this plus 1. Okay? So that's r outer. Whereas r inner is going to be equal to the y coordinate of this one, also plus 1. So that's going to be 8 sine of x plus 1. This is the most important thing. And this is the thing that screws up students all the time, especially when you start rotating about axes that aren't the X or Y axis. You need to account for what this constant like offset is. Because these functions here, when we have y and x, those are all referenced to either y equals 0 or x equals 0. So if you're revolving around this direction and you're finding like what the x coordinate is of a function, you have to also account for this. All right. So next thing, once this is done, now this is just calculus. I mean, it's all calculus, but I mean, now it's just kind of like more mechanical. So 0 pi over 4. So r outer squared is going to be 8 cosine x plus 1 squared. And then we're going to do minus 8 sine of x plus 1 squared dx. Okay. Same stuff. Pi. 0 to pi over 4. Let's expand this. I think I want to expand this, right? Or I guess this is also a difference of... No. I don't want to do difference of squares. What's up, Profi5? Good to see you. So 64 cosine squared x plus 1 plus 16 cosine x minus 64 sine squared of x. A donut! Wow! Thank you, Lewis. Lewis sent us a donut, and we're literally doing a donut question.
That's dope.
Lewis, thank you, dude. That's really fun. I don't know if you planned that, but that's sick. Okay, so then minus 1, and then minus 16 sine x dx. Fembox got 16 times 1 plus the square root of 2 pi. I could see that. I don't remember what the... Unfortunately, this isn't like cosine squared plus sine squared. Would have been so nice. This would have just been 1. It's not. That's disappointing. So, what is this first thing? Well, it's doing this. We're doing the volumes of revolution. It's a volumes of revolution question. If you want to see a screenshot of what the question is that originally got asked, that website down there on the live queue, you can click on Jose's name and it'll show you the question. Ooh, thank you, Jack-o'-lantern. My man, dude. Hell yeah, dude. Okay. Thank you, Jack-o'-lantern. Jack-o'-lantern reminded me of something that I totally forgot. I can group this and this to be 64 cosine squared x. I knew it was something. Dx. Plus 1 minus 1 goes away, right? And then we have plus 16 pi cosine of x minus 16 pi sine of x, right? So that gets rid of these. Yeah, this is cosine 2x. Very cool. That makes life easier. Okay. So we have this. Let's pull the 64 out. And that's going to be cosine of 2x dx plus... I can just do this right off the rip. So integral of cosine is sine. So we're going to have 16 pi times sine of x evaluated from 0 to pi over 4. Integral of sine is negative cosine, so that's going to be negative negative. So that's plus 16 cosine of x from 0 to pi over 4. And then this is a u sub. So the integral of this is going to be 1/2 sine 2x. So 64 pi times 1/2 sine 2x evaluated from 0 to pi over 4. This is going to be... Well, sine of 0 is just 0. So that's going to be 16 pi square root of 2 over 2 plus 16... I forgot there's a pi here as well, sorry. 16 pi square root of 2 over 2 plus 1 plus 16 pi. Right? because that gives you a square root of 2 over 2, and then it's minus cosine of 0. Cosine of 0 is 1. Oh, so sorry. This is minus then. Sorry. Okay. Sine of 2 times pi over 4 sine of pi over 2. Sine of pi over 2 is 1. So 64 pi times 1. Sine of 2 times 0 is sine of 0, which is 0. Okay, so then this is plus 32 pi over 2, so that's 16. How do you figure out you can do this? You just try, bro. Right? Just fucking go for it, dog. Okay. I think we're good. So 64 pi minus 16 is going to be 48 pi. And then that's going to be 48 pi plus 16 pi square root of 2. So I can pull it a 16 pi. And then that's 3 plus root 2. Did I screw something up? Might I screw up? What'd you get, Fem? He got 1 plus the square root of 2. Oh, shit. You hate how I draw pi? I'm sorry, dog. How do you draw it? Like this? Is this a better way to draw pi? I have a 1 where you have a 3. I agree. Why is that, Femvox? Why? This is the issue. Oh, wait. No. So the issue is... Sorry. The issue is here. This is the issue. I have a 64. Why do I have a 64? Well, it was 8 cosine of x, so that's 64 cosine squared, right? And then when you integrate that, you pull out a 1/2. No? Oh. Yes. This should be 32. Nope. I was wrong. I thought the law and the law won. Okay, good. Thank you. I think you said it earlier, actually, Jack-o'-lantern. Yeah, okay, there we go. That's correct. Nice. Nice. Looks good. You thought these were ends? They're not ends. They're pies.
Well done.
Sick. Good question, Jose. Jose, if you're in my Instagram, or it's not my Instagram. Sorry. If you're inside my Discord, I'm going to post this for you if you want it. Yeah. There it is. Post on all screenshots. Nice. Good question, Jose. Let's pull that off the queue. No, not that one. There we go. Okay. So, Nicola's coming back probably in 20-30 minutes. So, we'll get to her. Let me do clickbait. DM Schrader, noob at physics, then Henry, then Nicola. Yeah, that's. Let me see. How to join your Discord? So Discord. So that website where you went to submit your question. Nice. Welcome, Copter. Yeah, this is the place to be, dude. Don't keep scrolling, dude. You're just gonna see feet pics. It won't make you smart.
Disqualified.
Come learn calculus with us. Yeah, if you want to join our Discord, please. The website down there, actualdiscord.com/submit. There's a link here for join our Discord. Just click this, and you'll be able to join. And then yes, if you have to go, also click here for the streaming schedule. So this is a Google Calendar of all the times we stream. I stream 5 times a week now. Although I will not be streaming this weekend because I'm at TwitchCon, but I usually stream 5 times a week. Howdy, Dr. Gold. Nice mathing. Nice on. Okay, let's see what you gave me. DM's creator. What are you doing? God damn it, DM's creator. See, this is also the issue I have with allowing anyone to just upload images to my server. It's funny, DM's creator. Okay, but I have to delete that. I'm sorry. Okay. Clickbait. Oh, you didn't submit anything? Oh, well, your username got added for something. It's okay. Someone's probably trolling you. It's fine. I don't blame you. Bro, I got framed. It's fine. TwitchCon, yeah. I'm gonna go see some of the some of the other people we stream with. Yeah. It'll be fun. I'm excited to... I know Moohoodles is going. I think Science is going. I wish more people from the math department would go. It'd be fun to meet up with, what is it, like Zach and Penn. That would be fun, but it is a little expensive to go to TwitchCon. It's $250 for the tickets, and then you need to get a flight down to San Diego, and then you need to stay somewhere in San Diego. I luckily live in Los Angeles, so I'm only about an hour and a half, 2 hours from San Diego, and I also have a lot of friends in San Diego I can crash with, so 2 of those costs kind of just got neglected. But I understand it's expensive for everybody else. Yes, and the TwitchCon ticket is expensive. I agree. Yeah, and there's no discounts. Trust me, dude. Like, I tried. I'm like, yo, we're a nonprofit. Like, this is coming out of my nonprofit budget to go do this. But yeah, it is like $250, unfortunately. But it looks cool. I'm seeing it as a great networking thing, hopefully, to be able to collab with some other big streamers, maybe get our name out a little bit more, and get some cool podcast guests for you guys for the Golden Hour AMA podcast. Yeah, social capital is great. Yeah, exactly. Yeah. So I think we're almost at 2K subs here on Twitch. We've hit partner on YouTube. I think now is the time to maybe start leaning in a little bit more into we have some credibility as a streamer to get the attention, and I guess like just to get the time of day from some of these people. I remember when the stream was a lot smaller and I would ask people to collab and I just get fucking ignored. They're just like, who are you? Who's this person? So unfortunately, like social capital is a thing that you have to build. But it'll be cool. Yeah, maybe I'll live stream some of it for you guys. I don't know. We'll see. Okay. A particle in an infinite square well has the initial wave function. Wow. In the interval of that and 0 elsewhere, find the wave function at a later time. Okay, so you want the time-dependent Schrodinger equation? And the probability of energy measurements and the expectation value of the energy. Yeah, IRL stream. Apparently they have, like, a streaming center at TwitchCon where you can just, like, hop in and just start streaming. So, I don't know, maybe. That'd be kind of cool. I have no idea how to do this one. I kind of remember... I think I might honestly use ChatGPT to help me with this. I'll explain the steps, but this is quantum mechanics, which I have taken many times when I was in my 20s. I'm now currently in my 30s, so I don't remember all of this, but I can figure it out. What does a square well look like? Can you draw it, or is it... No, it's totally drawable. Yeah, for sure, dude. You want to see what a square well is? Yeah, no, I'll show you. Yeah, quantum mechanics is weird. No, I'll get you. No, it is. It's actually a lot of it's a lot of statistics, honestly. A lot of linear algebra too. There's a lot of like matrix operations and stuff. Yes. Yeah, that's it. Yeah, e to the I mega negative. Yeah, that's the time. You just strap a fucking sine wave on it, and now it's time dependent. Anyways, yeah, this is what like a square well is. Oh, I guess hyperphysics has some good explanation. I love hyperphysics. Yeah, here we go. Particle in a finite walled box. Yeah, given a potential well and a particle that has energy less than the height of the well. And when we talk about height, it's not like physical height. It's like energy height. They're talking about like how high of an energy you would need to do in order to escape the trap. Yes, and then you can have odd or even parity. So that depends whether your boundaries are continuous, I think. Well, whether it's symmetric. It's either odd or even symmetric to the center of the well. No, it is very similar, jokes. Yeah, no. E to the yeah, in electrical engineering, they use J instead of I. Because I is used for current and J is not used for anything. Although like technically in physics, J is like current density, I think. Yes. No, but the reason behind that, Jokes, is that e to the I omega t is basically just a sinusoidal variation. What's up, Nightmare? Hey, good afternoon. I have an ASVAB test coming on. Awesome. You've been struggling with math, and I have been out of school for 7 years, so getting back to these subjects are killing you. I understand, dude. It's rough coming back to school, but don't worry. I teach tons of students that are in their 30s, 40s. I've even taught like 60-year-old students who have been out of math for a while. It'll come back to you. It's like a language. Best thing to do is to practice and kind of like evaluate where you're at, and then kind of like figure out the found nightmare on the stream. The best thing for you to do would be look at like one of your ASVAB like practice tests and take a picture or a screenshot of one of the questions that doesn't make sense to you, and I'll explain it to you. You're 34? That's cool, clickbait. I'm 35. Yeah. I'm not a boomer, but I'm a millennial, which I don't know what the kids call millennials these days. Okay, do we just want to cheat and do what the eigenstates are for the 1D potential well? Because I could do that, right? This is like all the ground state stuff. Do you have any resources for AP Physics C? Really? Khan doesn't do AP Physics C? That's fucking whack. I do actually. So, P Physics. I wrote like a website thing for this at some point. Where was it? Here we go. Yeah, no. I literally did a, here we go. AP Physics C, I did a whole review for this at one point. I forget though if you click join the Discord if it's gonna, I don't know if I have this live now in the Discord. Fuck, where is this? I will say this, when it gets closer to the AP Physics C exam, come back and ask me, because I do always run like a review course like the month before the exam. And then I do like videos on them too. So I'll do like live stream walkthroughs on the FRQs. So if you want to see my previous ones, I have them on YouTube here. Just type in like AP Physics. There, where is it? Here. Oh, I did AP Physics 1 in 2023. I thought I did AP Physics C. Did I not? AP Physics. Maybe it was 20. Was it 2025? Oh, it's always AP Physics 1. Okay. Yeah, okay, sorry. I've always done AP Physics 1. I can also do AP Physics C. I'll probably do one this year or next year. Still got my slide rule. Nightmare says, I'm 26 and I've taken practice and scored a 40, which is passing score, but my is just fractions and arithmetic. Totally. I understand. Yeah, like just basic figuring out that type of stuff. Here, Nightmare. If you want, I have a whole like remedial math course that I wrote. I'm gonna show it to you real quick. It's with a company I work. So here you go. It's called Kudu. I can't even spell 1986. But where was it? It was a part of summer camp is what it was. Yeah. So we had a summer camp in 2025, but I had these chapters here, so core math skills, and I wrote a lot of this. And it goes through, for instance, like how do you convert units? How do you perform calculations using order operations? How do you deal with exponents? How do you deal with radicals, square roots? How do you simplify algebraic stuff? Systems of equations. Yeah. Join our Discord. I'm Dr. Gold. Just at me, and I'll get you access to this course because there's a bunch of practice questions as well. And in addition to learning from like the textbook thing I wrote for it, you can also figure out how much you know by doing practice questions. Yeah, check it out. Yeah, so the website, again, actualdiscord.com/submit, and then if you click on this button here that says join our Discord, just join the Discord and just at me, or send me a DM, and I'll point you in the right direction. I should make it easier for people to find that, but yeah, yeah, I got you. Okay, okay, so this is an infinite square well that has the initial wave function this. Yeah, it is usually square root of 2 over L something, right? Yeah. So, yeah, let's come up with what the wave function is for a... Let me think. Wave function for 1D Infinite square well. Yeah, totally. Just DM me. DM me. I'll do it. Yeah, just DM me. Oh, here it is. Bingo. Love it. Yeah, the summer camp thing. Yeah, totally. Yeah. Yeah, we run it every summer. I do kind of it's a virtual summer camp, so we have like a chess tournament, we have a talent show, we have a bunch of video game tournaments in like Fortnite, Warzone, whatever, Roblox. And then I also do kind of a refresher course in math that students go through. You get points, and then whoever gets the most amount of points has the best chance at winning a big prize. And then this year I gave out a Nintendo Switch too. Ethan won it. Ethan won the Nintendo Switch. But I'll make that course available like during the year because it's a great refresher. Okay. Yeah. Clickbait says we need to normalize the time dependent function. Okay, well, this is the time independent function, right? This is the, and what we know in order to normalize, right, is that rho star or psi star, this has to be equal to 1, right? That's kind of the that's the requirement, right? And then sorry, oh, this is at t equals 0, right? Yeah, I think that's what it is. Okay, cool. So it's always fun because you can also do this in like Brocket notation, right? I think this is like Brocket notation, right? I think this is what it is. You've been using the integration formula. Okay. That's another way to do it. Sure. Okay. Differentiate. Okay, yeah, okay. All right. These are the eigenstates, right? I'm pretty sure these are the eigenstates. So these are the different states we can have for it, right? And then these all have coefficients on them. So, let me think how this works. Take the function twice and plug it into Schrodinger's. Okay, we can do it from that. Yeah, okay, sure. We're doing this kind of from like first principles. This is H psi E psi, right? Yeah, okay, this is what I'm thinking about. Yeah, here we go. Okay. On this stream, we'll watch Dr. Gold struggle with quantum mechanics. Okay. Yeah, H psi equals E psi, right? Where H is negative H bar squared over 2m d squared dx squared. And it's equal to the energy of the eigenvalue states, right? Where I think for the infinite potential well, it's like n squared pi squared H bar squared over 2ml squared, yeah? Oh, fuck. Yeah, something like that, right? Okay. Okay. I know that psi of x0 has to be equal to a bunch of these coefficients, right? From n equals 1 to infinity. I'm going to say like c of n times what the eigenstates are. So this is like psi n, right? This is the entire wave function, and these are like the individual quantized energy states you can have, right? And then in order to figure out the coefficients, what's that? Coefficients. Oh, don't we have to normalize this, though, with respect to A? Something like that. One sec, I'm looking stuff up. Oh, okay. Yeah, wait, one sec. Let's chill. Let's chill for a second. I think I want to figure out what A is. This is true. Let's do this first. Okay. In order, wave functions kind of match. They pick out what the probability is for a particle to exist in a certain energy state and a certain, which energy state is related to an eigenstate. But the main thing here is that, like, integral of psi star has to be equal to 1. Or I think it's psi star psi. I forget which one it is. I think it's this. Luckily, this doesn't have any complex components on it, right? And where Bra-Ket notation here means the integral from 0 to infinity, which in this case is 0 to L, because the wave function is only defined for 0 to L. It's 0, it's 0 anywhere else. And so this is going to be A squared. All of this shit squared. Conjugate first is correct. Okay, cool. All right, I'm just going to copy this in. There we go. So it's this squared dx, right? Uh-huh. And this all has to be equal to 1, yeah? Let's maybe... I maybe see a u sub situation here, right? Because I see the same thing. So let me say, let u equal to x over L. So then du is equal to 1 over L dx. I can definitely do derivatives. I mean, I'm doing integrals right here, dog. So a squared, 0 to L. And then this is going to be u to the third minus 3/2 u squared plus 1/2 u. All squared. Times L. So a squared L. So then du is equal to 1. This is kind of a messy integral, right? Oh man, this is a fucking bitch, dude. What? I gotta go in and square all this? Fine. A squared L. Okay. What is this? Integral from 0 to L. This is gonna be u to the 6th minus 3/2 u to the 5th plus 1/2 u to the 4th minus 3/2 u to the 5th plus 9/4 u to the 4th minus 3/4 u cubed plus 1/2 u to the 4th minus 3/4 u to the 3rd plus 1/4 u squared. Dude, bro, this sucks, dude. What? And then I gotta do this all with L's? The last problem ended up with 9 separate trig functions to integrate over. It was a nightmare. This just sucks, dude. What? Alright, fuck this. I'm gonna... Well, because I don't want to calculate all these fractions. They're kind of a mess. Well, I guess it goes from 0 to L. So it's not the worst thing in the world. Because all the zeros are going to go away, right? Okay, so... What's that? L to the 6th? Oh, wait, whoa, but my bounds have changed. Sorry. If I go from 0 to L, now U goes from 0 to 1. Ah. That's actually kind of nice. Yeah, or that U sub is nice. Okay. So 1 minus 3/2 plus 1/2 minus 3/2 plus 9/4 minus 3/4 plus 1/2 minus 3/4 plus 1/4. A squared L is equal to 1. So what is that? 1 and 1/2. Well, I'm doing quantum mechanics, and I'm getting hurt. 1 and 1/2 is 3/2 minus 3/2 is 0. Minus 3/2. Wait. This cancels with this. One over 4 2u minus u minus 1. Wait, where'd you get that from, Jack? Wait, what? Excuse me? Oh, sorry. I didn't even do the integral yet. Bro, that's just the foiling. I just foiled. I didn't even do the integral yet. Oh, no. Yeah, sorry. I have to then do all these integrals. No.
Surprise, motherfucker.
No, I'm not doing it. Not doing it, dude. I'm not doing it. I'm going to take Jack-o'-lantern's little thing here. Okay. He said this factors to... Okay, great. I'm going to trust you because, like, fuck this, dude. I'm not doing this. 1 over 4, 2u minus 1, u minus 1. Oh, but then this is partial fractions, no? Oh, no. Okay. You know what? Sometimes you just need to use... This is monotonous. I'm not learning anything new here other than I fucking hate quantum mechanics. So I'm just gonna get ChatGPT to do this integral. I don't care. Yeah. Oh, bro. Okay, wait. I need to hear from Nicola. Okay, I just came back from office hours, and he went on a rant about how physics can't be easy, and that in the past he has spent months, if not years, working through a problem. Did you ask him, is that problem how you're paying rent? No. If you really just want to like go for violence, Nicola, like please feel free. Like, is that your problem, dog? You've been working on? Also, Nicola, you are in Physics 5C, which is not for physics majors. It's for life science majors. It's a requirement for people who are pre-med or whatever, pre-farm, like bio people, to take some physics. There's no need to be giving physics a bad name to just like fuck with you guys to give ridiculously hard questions. Like, keep that shit for the physics majors. He said 5 to 6 FRQs in the midterms, and that's 50 minutes. I couldn't do it. I would love to see him do it in 50 minutes. You probably can't. Okay, let's see. What do we got? Okay, so this was the integral. I like this. A is equal to 2 times the square root of 10. Well, I think something's wrong here. A squared over 140. Oh, wait. I think it got my integral wrong here. It's okay. It is just monotonous. Look here at ChatGPT, what it is. you expand the square, which was what I did, and then you have to integrate everything term by term from 0 to 1, but that's 1, 2, 3, 4, 5 different integrals. And then you have to add them up and get common factors. So I'm just going to go over, I'm just going to say it's 1 over 840. That sounds great. Yeah, this whole thing is 1 over 840. Okay, awesome, cool. Work smarter, not harder. Okay, so a squared L times 1 over 8, no, times 840 is equal to 1. Okay, so a squared is equal to 1 over L, 1 over 840, which, yeah, sure, this is 4 and 2, 10. So you can pull out a 2. So A is equal to the square root of 1 over 2L square root of 210. I think, did I do that right? A squared L. Take the 2 out. Fine. Take the 2 out. Oh, Nicola says, please come back for 5B in the winter quarter if you can. I really want to, Nicola. I do. Trust me, I went to the department. You guys wrote me the best reviews. I really appreciate it. Like, that really helped my case when I went to them. I was like, look at these reviews. Like, I think I do a pretty good job teaching here. It's just... It's unfortunate because the department can't really do much because their hands are tied. And also, I just get this feeling that they don't want to do much because they're professors. The people who are like the department chair, the people who are in charge are basically middle management. And you have these career fucking institutional admin people above them who their whole job is just to like make things difficult with like finances and stuff. And so they tell these professors who are in charge of the teaching and the hiring that like, hey, this is the budget, you got to deal with it. And unfortunately, the department is a bunch of physics professors who are not experienced in the way of corporate admin mumbo jumbo. So they just accept it. And they're just like, okay, cool, I guess that's what we have to do. And then you the students get kind of screwed. So I'm sorry. It's frustrating. Trust me, it's frustrating. It's incredibly frustrating. Okay. Yeah, and then okay. Here, clickbait. I'm gonna punt on this question just for a second, just because it's a very long question. It's cool. I appreciate you giving it to me, but let me help out people who are like have tests tomorrow. Like Nicola has an exam coming up, and I'm just getting more mad at quantum mechanics.
That's dope.
No. I actually failed quantum mechanics in grad school. Yeah, it was, and by fail in grad school, if you get a B-, it's failing. I got a B- in quantum mechanics, and they withheld my funding for like a semester. It sucked. Yeah, grad school's fucking brutal. Looking back at it, I'm like, holy shit, dude, what? Dude, imagine they just like cut your income because like you got a B- in your class. Yeah. All right, Nicola, which one do you want me to go over? I'm punting on the. Someone else. Who was this? Sorry, Noob at Physics, by the way. Yeah, Noob at Physics. You also submitted one. Problem 4, Nicola. Okay, cool. We'll do it. Noob at Physics. If you're watching, please tell me if this is one of your questions. I'm gonna pull up Nicola's as well. And then Henry, I see yours as well. You got some good pulley questions. Wow. It's a cool one. Pulley question's cool. Okay. The sphere one. Okay. Is that this one? A spherical conducting shell with outer radius B and inner radius A has a total charge Q. At the center of the sphere is a point charge positive Q. Find the electric field as a function of the distance from the center where R is greater than B. Okay. That's not too bad. This is actually a gimme question. Where this gets harder is when R is less than B. So, Nicola, whenever you're outside, this is right, the Gaussian surface. I don't give a fuck what the shape of the charge is on the inside. I just care about, is it spherically symmetric, and what's the total charge? Yeah, this problem is like 2 seconds. It gets more difficult if you want me to figure out the electric field here. I agree with that, but for outside, this is cake. So, integral of E dot dA is equal to Q enclosed over epsilon naught. Exactly, Chris. So this is E times 4 pi r squared. The enclosed charge is positive little q and big Q. So it's just little q plus big Q all over epsilon naught. So then E is equal to 1 over 4 pi epsilon naught little q plus big Q all over r squared. I will do it. Yeah, that's the harder question. So this is K little q plus big Q all over r squared. And you're done. This is cake. Let's make it harder. All right. Yeah, let's go. And then also, Nicola, just while I'm on that topic, if you were finding the electric field inside here, then it's just K little q over r squared, okay? Because now you're only enclosing the little q. Also, like, this is drawn, like, terribly, bro. Like, where's the center of this chart? This is, like, not center. God damn it. I get mad for you. I get mad that some people get hired to teach and are absolutely terrible. And UCLA is supposed to be, it was last year, the #1 public college in the United States. I think it's #2 now. But this is, like, not representative of the #2 public university in the U.S. This is garbage. This is trash. Now it's Berkeley. Yeah, it almost always is Berkeley. But for whatever reason, it wasn't, like, a year ago, and UCLA just went all out and bought all these banners, all these billboards. You want to know where my teaching salary went? It went to all this fucking promo bullshit of, like, we're #1. It's like, okay, how about you spend some money on the teachers? You left and it became #2. Oh no. Oh no. That's so right.
No.
Nicola, wow, I left, it became #2.
No.
I love that.
No, no. No.
Okay. All right. Same thing. So E times 4 pi r squared. Sorry, this music's a little loud. Let me turn this music down. Bothering me. There we go. Much better. Okay. E times 4 pi r squared is equal to Q enclosed over epsilon naught. So we got to deal with what Q is being enclosed here. Okay. So you definitely have the positive Q being enclosed. Okay. So Q enclosed definitely equals little q at least. And then it's plus, I'm going to say, like, the percentage of big Q. So big Q is like this whole thing, right? This whole donut. Thanks, brother. Appreciate you loved the content. But I want to know the percentage of big Q, which is being enclosed as my, like, radius gets bigger and smaller, right? And it should be symmetrically going in and out. All right. So the way to do that, this percentage of big Q, this is always a volume thing when it is, okay? So this is proportional to the volume enclosed divided by the total volume. Or, see, volume and vol enclosed over vol total. Okay. So now let's figure out what the total volume is for two concentric spheres. All right? So V total is going to equal to 4/3 pi big R cubed, right? Minus, and big R in this case, sorry, is, this is B. And then this is A, right? So it's 4/3 pi B cubed minus 4/3 pi A cubed. You see how that's the total volume? Because what you're doing is you're taking this minus this, and then that's giving you this. Right? That's how you find like the donut part of the volume. Okay, so that's V total. So then V enclosed. That's 11, Ayland, I think. So V enclosed, good. Why R cubed? Because it's a volume. So volume of a sphere is equal to 4/3 pi R cubed. So maybe let me show it this way. Is this Maxwell? No, this is Gauss's law. Sphere volume. Exactly. Thank you, Jack. You're so right. I'm gonna draw some pictures. We love pictures, right? Pictures are fucking great. Oh, it is one of Maxwell's? Oh, my bad. I don't remember. Okay, and that's what this is. Okay. Why wasn't the other one? I'm going to show you why. I'm going to show you why. Because you have to do... because the R's will cancel is what happens. Because first of all, this has like a 4 pi R squared over here. This Q enclosed that we're dealing with will have like some R cubes on it, and when we divide them out, you're going to get like just over R. Or like an R on the top or something. Yeah, surface area, exactly. Okay, so V enclosed is now equal to 4/3 pi R cubed. Okay, this is the R of where I'm enclosing charge, where I'm looking at my electric field, right? This is like where we measure E. Minus 4/3 pi A cubed. Okay? That's the proportion. So this is the total volume in like the shell. Right? You kind of think of it like this. And then what we're doing for this, for the volume enclosed, we're looking at like a smaller amount of it. We're looking at... Here, let me get rid of this. Does that make sense so far, Nicola? I know there's a lot going on here. Cool. Okay, cool. All right. So, percentage of volume is equal to V enclosed over V total. So, let's hold this. Oh, sorry. So that's this divided by this. So the cool thing is, you can actually just pull all the 4/3 out, right? So it's really just, well, all the pi's cancel, right?
That's dope.
Yeah, pi's cancel. Wait, all the 4/3 cancel too, actually. What the fuck am I talking about? Oh, everything goes away. That's actually really nice. Okay. R cubed minus A cubed over B cubed minus A cubed. Okay, and then Gauss's law from before, right, is E times 4 pi r squared. So you have E times 4 pi r squared is equal to Q enclosed, which is the percentage of the volume, times Q all over epsilon naught. So 1 over epsilon naught. So, eventually you get E is equal to 1 over 4 pi epsilon naught. And then, I mean, you're dividing by r squared, so what's that going to do? That's going to be r minus a cubed over r squared all over b cubed minus a cubed times q. And then this is just k, right? Cool. And then you can always kind of look at the limiting case, right? Why wouldn't the a... Because it's not by itself. It's like two things in a fraction. If you have like 3 plus 7... Sorry. If you have, for instance, like 7 plus 3 over like 4 plus 3, you can't just like cancel this. Right? This is actually like 10 over 7. If I just canceled these, I would get like 7 over 4, which is wrong. The A would need to be present in every single thing. Whenever your denominator has weird shit like this, yeah, you can't really mess with it. Why not, Jack? Yeah. Okay, I think I'm right here, right? Yes, we assume also, yes. Well, I assume this is a vacuum. Yeah. And then the key thing you want to see is, like, does it reduce down to what you wanted when R is equal to B? Right? So when R is equal to B... Okay, so when R is equal to B, you get b to the third minus a to the third of b to the third minus a to the third, right? This all goes to 1. And then you're left with the exact same thing you had. Oh, sorry. And then this is... Oh, sorry. It's plus q over... Sorry. I forgot. We're also enclosing... There's a charge q in the center, Nicola. So this was just for the charge due to, like... the donut-y part of it. And then you have q, you have kq over r squared. Because this technically needs to do plus q over epsilon naught. You have to divide it by both things. Yeah. Kind of a bitch. Yeah. Pretty sure it's right, though. Okay. Yes, we assume that... Yes. We assume that the charges... Well, in this case, they would have to stay, right? If you have a positive charge in here, and you have a positive charge on the surrounding ring, like, this charge isn't going anywhere. It acts like a spring, right? It keeps it in the center. They're both positive charges. They're both positive charges. Well, actually, we don't know what the charge is on Q. But regardless, it's spherically symmetric, jokes. So if something's in the center here, the Coulomb force between this and the outside disk will always keep it in the center. It's either all going to pull on it with the same amount of magnitude, or it's all going to push on it with the same amount of, like, magnitude and, like, canceling directions. Okay. Right. Okay, so that is... Yeah, right? Yeah, symmetry is beautiful sometimes. Okay, Nicola, that's 4. This, I hope, was just kind of easy. For A, I guess, yeah. Cool. Nice. Let's see, what question was that we just did? That was problem 4, so that was number 2. Okay. Let me clear out number 2 then. Okay, bum. Nice. Okay. Where is noob at physics? And then Henry, and then I'll do another one of clickbaits. I'll try more quantum mechanics. Not this, not this, not this. That was my kudu course. Nope. I'm just going through all my tabs. Bun cakes. I did send it. So, Nicola, you want to just join my Discord so it's easy? It's easier. Do you have Discord, Nicola? It's just easy for me to just like keep dumping things in a channel. There's a thread. Yeah, there's like an office hours thread. I don't think I did all of number 1, by the way. Sorry, I just did number 1. I only did part A. There's a little bit more to it. Francesco, ciao. What can we ask you? You can ask me anything. But I can help you out the most if it's something middle school, high school, or like early college math or science. Those are the types of questions you can ask. So we've had students asking physics questions. We had this was a calculus question. Someone was asking about like volumes of revolution. This was another physics question we did. More physics. Okay, cool. Oh, part B for this, Nicola. This is easy. You just for this one would just set R2 equal to infinity. Right? So, this just goes to 0. One sec, my mic went out. But yeah, so for part B on this one, if R2 goes to infinity, 1 over infinity is 0, and so then it's just, you just ignore this term. And then what was the other question here? It says, if instead of moving was an electron with the same initial conditions, describe qualitatively the subsequent motion, will it escape or be bound? Who? So if it was an electron, now it gains potential as it goes away. So you end up flipping the sign of this. This becomes 1 over R2 minus R1. And then what you have to see is whether that ends up making this whole radical negative. If it breaks the radical. If it breaks the radical, then you don't have enough energy to escape. Yeah. Yeah. What's up, Thomas? Okay. Is Henry still here too? This is a good one. I like this one. Yeah. Okay. What's up, Henry? Let's do yours. And then Nicola, let me know what other ones you need me to work through. I have another hour. I'll stream if you need help. Or if you need help with like getting on the Discord and joining that and where the stuff is, please let me know. I'll help you out with it. Okay, starting from rest, the cable can be wound onto the drum of a rotor at a rate of 3 t squared meter per second, where t is in seconds. Determine the time needed to lift the load 7 meters. Ooh. Okay. Okay. So I don't think this matters. I mean, what these pulleys do is they enable this rope here to pull a very heavy thing. So you can pull really heavy things if you nest all these pulleys on top of each other. The only difference is it then takes a lot more rope to do it. But I think what's conserved here is always the energy, right? So work is equal to force times distance. So, and then work has to be equal to the change in energy to bring this thing up, for instance. So if you can exert a larger force on this because you're using a pulley system, you end up needing, I thought you need more distance. Sorry, if the force required to lift this thing is a lot lower because you have a pulley system, the distance that the pulleys need to turn becomes a lot more. Yeah. Taco Cat says, Gold, do you still have childhood friends or friends from high school? Bro, I have friends from elementary school. Yeah, no, I seriously, I do. Yeah. One sec, I got a picture. I'll just show it, just for, yeah. Friendships can last very long times. They're really cool if they do. Oh, I gotta refresh this. One sec. mg minus c equals mf for the first mass. Yeah, and then but it's gonna get more and more complicated, right? Here, yeah. You want to see a funny photo? Yes. Yeah, let's do that. One second, let me get that up. Here, Taco Cat, I'm gonna show this to you just for like kind of funsies. Also, shout out to my friend Michael, who has supported me in a lot of things. Here you go, Taco Cat. This is an example of a very long friendship. This is me and my friend Michael when I think I gotta be like 12 years old here. Maybe 13. And then this is me and him this year when I'm 35. So that's 22 years of knowing each other. We still keep in touch. Okay, let's do this one though. If v equals t squared, then s equals t cubed. So displacement of load is that. I hope to have a long friendship. Yeah, you will, man. The real ones stick around, dude. I think it's FVDT. Yes. I think I can just do it with energy, though, no? So, yeah, okay, so force times velocity, right? That's equal to power. So let's see how that works, right? Because integral of f dx is equal to energy. And if I do ddt of both sides, that's integral of force times volume is equal to power. Can you use it? Can you do it using the rope length equation and the difference? Yeah. See, I want to use I want to use energy because this is just I think it's easier with energy. But we can. Okay. Also, energy times time is power. Yes. Okay. He wants to use the rope length equation. What? Sorry. What's the rope length equation? Sorry. What? I got you, dog. Here we go. Pulley formula. What the fuck is going on here? Oh man, what the fuck is this question? What? Morin calls it conservation of string. I love that, conservation of string. Dude, what is going on? What is all these other whack-ass things that happen, dude? What? Is it this? Is this the equation they want you to use? Is it this? That looks... That actually, sorry. This looks like something specialized for, like... a fan? No, I don't want this. Maybe, can we do this? Can I do it in terms of velocities? Okay, wait, he says, no, like, the length of the string that changes plus the constant length equals the total length. You derive the equation into velocity and the constant is 0. Okay. Okay, Nicola, what's your username in Discord? Can you tell me what the username is? And I'll just tag you it. I agree with what Chris says. I would love to just do MGH as integral of MGVDT. Yeah, I don't know what all the pulleys are. Okay, cool. Got you. I just tagged you. You should see the notification for where it is. DLDT is equal to omega. Well, they already told me. They already told me the cable. They already told me what that is. They said VA is 3t squared. I agree. Okay, so let's think. So if this gets pulled in a meter, right? And then we're saying, like, how much does this get pulled in? No, I think we just consider the linear speed, Chris. Okay. If I pull this a meter, then this must total come up a meter. So this must come up half a meter, and this must come up half a meter, right? Right? Okay, cool. Okay, and so if this comes up half a meter, then the whole thing should come up of a quarter. Okay, let's write it this way. I like Femvox, thank you so much. I just needed the math. dAdt is equal to 2 dddt, which is equal to 4 dcdt, right? So it's a factor of 8. 8 dBdt. Okay, I like that. Awesome, cool. All right. dAdt is equal to 3t squared, right? So 3t squared is equal to 8 dBdt. Do we understand that, right? So every time you go to another pulley, it's another factor of 2. Okay. And then you just integrate this, no? Right? So then 3t squared over 8 dt is equal to dB. And then I'm integrating dB from 0 to 7, right? And then I'm integrating this from 0 to, like, t final. So then that's t cubed over 8, 0 to t final. And then this is equal to 7. I guess there's technically a plus c or something, right? Oh, no, they're definite integrals. Okay. So t cubed is equal to 56. What's the cube root of 56? I don't know. I don't think it's anything nice. What's that? 2, 28, 2, 14, 2, 7. So, TF, you get a triplet of 2's, 2 squared of 7. Cool.
Good job.
Is that it? 4? It's almost 4. Okay, I think that was it. Here, let me throw this in ChatGPT. No, not this one. Solve. Go, my darling. See what happens. Bum, 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 bum. Let's see if it gets it. I'm just curious. I keep on getting recommended this. I guess this is the powers that be making me stop procrastinating my physics. W algorithm. Okay. I want this to solve. Come on, ChatGPT. What do we pay you for? You should be able to see it. You should be able to get this. This is an easy question. Okay. What happened to the b in the integral of dB, and why is it not b? Any bound you plug in does nothing because there's no more variable? No, it does. Okay, so what happened here, if I integrate dB, that just becomes b evaluated from 0 to 7. And so that just becomes 7 minus 0. There it is. I tagged you in it. Hike. It's in the office hours stage chat. I should dump these in another place. Yeah. Here we go. Cube root of 42. Wait, ooh, we got cube root of... oh, fuck. Wait, what? We got the wrong answer. Uh-oh. It says 6 rope segments? So it says not 8. Oh, ooh, why is that? Why does it think 6? It doesn't think it's 8. Let's think about that. Wait, whoa. Okay. If this pulls down at 1, wait, this one doesn't move though, fam, right? Ask if 8 can be correct instead of 6. Okay. It says there's 6 rope segments. In the diagram, the load is attached to the bottom pulley block. 3 pulleys. Each of these pulleys changes the rope direction, but doesn't multiply the tension. They all share the same rope. For each moving pulley, the rope passes under it and goes back up. Each such contributes 2 rope segments that support the load. If there are 3 moving pulleys stacked on the same block, the first contributes 2 rope segments, the second contributes another 2. But, yeah, no. I think there's more than, there's 4. It might feel like each pulley halves the motion, but that doubling only happens once per independent moving pulley system. Here, the 3 pulleys are not independent. They're part of the same continuous cable. So the overall mechanical advantage equals the total number of rope segments. Yeah, I think it's screwed up. I think it's screwed up on this, right? Can we agree? I think it messed up on that. Okay, I mean, ChatGPT gets things wrong. That's okay. Good joke. Joke was asking here. Yeah. So when I got down to here, jokes. Okay, dB refers to like the distance of block of pulley B, right? So we said pulley B, right? And so the distance of pulley B goes from 0 to 7. That's why that's those bounds. Okay? The time that's the time to pull B up. And so that goes from 0 to T final. This is a common thing you'll do in physics. You'll move something over. You'll integrate this from the time when the position is at 0 to the time when the position is at 7. The key thing is that the starting point and the ending point of your integrand need to represent the same, like, moment in the question, right? So here 0 represented 0 distance. T final represented 7 meters of distance. They're 2 different units, for sure, but they describe the same point in the question, like the point in time, like starting versus final. Yeah, boundaries is the word. Exact. Thank you, Akman. They're bounds, right? But you can be bounded in time, and you can be bounded in position. Okay. Let's see. Nicola, you need help with... what did you say here? Sorry, let me go find it. I just need help with part C, the first one. Yeah, okay. So, the first one... why is the first because it's dB. No. The right hand is integrated with respect to dB. So the key thing here is that this is dB dt. So dt goes over here. So this integrand deals with time. This is still dB, so this integral is with respect to the position. you can split integrand. You can split derivatives into two separate integrals on each side. All right, we don't need that. That makes sense. Cool. No, I'm glad it does. It's kind of a weird thing. A siege. Okay, cool. Let me help Nicola with this one, and then a siege. I got you. Leibniz would turn in his grave. Yeah, bro. Believe me, people get so mad at my implicit differentiation video because I just I divide by d whatever. I'm just like, I don't give a fuck. It works. Thanks for the roast. Okay. So when it's very far away, Nicola, right? You're very welcome, Hike. Yeah, feel free to. I love these types of questions. They're great. So as R goes to infinity, R2 goes to infinity, you just cancel this and just recalculate. What's a little different here is they say instead of the moving particle, if instead the moving particle was an electron, but a different charge with the same initial conditions, describe the subsequent motion. Okay. Yeah, dude, hand-wringing about dividing by differential. I agree, dude. Good to see you, Mathematic Fanatic. I super agree, dude. I think some math people get on their high horse about shit, and then it just scares kids, and then they don't want to study math, and then no one can be part of the Math Cool Club. Yeah, literally, if it works, then it's math. Exactly, I agree. Okay, so, Nicola, what changes is that if the charge of our particle is now an electron, this Q here will be negative, okay? And if this is negative, then the order of these things switch. So, if you have, like, negative A minus B, Nicola, this is the same thing as B minus A. So, what I'm going to do is I'm going to take my original question here. So this is for part C. And this will now be a negative, so I'm just going to switch the orders of these. So this is just going to be R2 minus R1. Okay. And then our job is to see if this thing is still like a good square root. Like if it's not imaginary. So I think I still have this saved in my calculator somewhere. Where did we do it? Okay, it was this one. So we did this, 90 to the 12. And then we did plus all this hot garbage. Okay. But I need to switch the orders of these. So this is going to be 1 over 2 minus 1 over 1, I think. Oh, fuck, no. Okay. So this does not work. Do you see how I get a negative number here? So this is bad. So all of this, Nicola, is now negative. And so this is a problem. Because the square root of a negative number, not a really good thing, right? So, this means it does not escape. It would need to have imaginary velocity to, like, run away. It just doesn't work. Yeah. Mathematic Fanatic says, why do you use the TI emulator instead of Desmos? Good question. The reason why I do that, is because students, a lot of times, are allowed to use a TI-84 in their class, like on their tests, or they're allowed to use it on the SAT, or, like, whatever. So I think it's really important to show students like what buttons to press to do things on the TI-84. So that's why I have the emulator. Because I remember at least when I was in high school, middle school, the teacher had like some cool little thing that went on the overhead projector and you could see like what was happening on the calculator. I don't know if they do that anymore, but yeah, Desmos is allowed now on the SAT, which is cool. So I agree there is now some use to showing people how to do things on Desmos, but for the most part, I still live in the land of you get a TI-84 on your test, and I love being able to show students, for instance, like, you know, how do I get to like matrices and stuff? How do I do RREF on a matrix? Like, all this stuff is very cool. Or like, how do I graph? How do I intersect? How do I do plots? There's so much cool stuff you can do with the TI-84, but I don't think it's really ever taught to students. So that's why I'm a big fanatic of it. Yeah. Make, you are correct that the negative square root is I. The issue is that in physics, when talking about the velocity of something, I don't want the velocity to be imaginary. What do I think about Desmos on the SAT? No, you're okay. I think it's, I think maybe it's cheating. I mean, I think Desmos is really cool. I think it is very good to test people on like how to use tools. But I think Desmos is like a little bit too overpowered, I guess. At least for myself, for teaching students to do well in the SAT, it completely upended the way I teach. Because now instead of showing like the cool math tricks to do stuff, you can brute force a lot of the questions just with Desmos. And I don't know, that kind of takes the... I mean, there's a skill to brute forcing, don't get me wrong, but... yeah. Plus, it is gold obtuse. Yeah. This is undergraduate physics is what this is. Yeah, undergraduate physics. Okay, so Nicola, if you're still watching, please let me know if that makes sense. I'm going to drop this in for part C for you. And then let me look at the queue. What do we got? So I think Nicola, I've answered all your questions. So I'm going to clear yours off. Just. And then I think Henry. Did we just do yours, Henry? Right, that was the pulley system, yeah? Okay, clickbait was that. Nubit physics I'm waiting on. A siege I'll help out, and then Yadavir. I don't do much solid state or particle physics. No, I don't. Unfortunately. I took those classes as an undergrad. I don't teach them. Look at this beautiful bundt cake we had for this volume of revolutions. It was delicious. Okay, a siege. Where are you at, a siege? What do you got for me? This is cool, but like, what's the question? Maybe a siege? Okay, Nicola, that's okay. If when is your test, Nicola? When is your test? Is it tomorrow? I 100% agree. Mathematic fanatic, yeah, it does make sense to use computer tools. Okay, so we still have tomorrow, right, Nico? I mean, I will try to get to your last one. I just might run out of time because I have to teach in 28 minutes. But I can definitely do it tomorrow. So you can come back tomorrow. Awesome, cool. No more quantum. I'll keep it easy. I mean, I like no. It's okay, clickbait. I like that quantum. It's just maybe when I'm not like so slammed with other students that have tests that are coming up soon. But please ask them. Like, it's don't ever feel restricted about asking things. Because I enjoy the challenges. Holloman says, "Do you have any advice for applying to a PhD programs in physics?" Yes. The number one way I got into my physics PhD program is because I had research experience as an undergraduate. So I will say, if you want to do your PhD in physics, go get some research experience as soon as you can. I did it my first year of undergrad. I realized very quickly during Christmas break that I did not want to go home for the summer.
Surprise, motherfucker.
Because going home sucks, especially when you start, I don't know, tasting the freedom that is college. So I made it my goal to like get a job that summer at least. And so that spring before summer, I went to every single person in the physics department and I said, "Hey, do you have any advice for how I can get involved in research?" That's always the best thing. Never ask people like, can I have a job? Ask people for advice on getting a job. People love to give advice. They just love to feel relevant. They love to feel like I'm helping you. If you say, I need something from you, like I want a job, they won't give it to you. But if you say, I need some advice on how to get a job, they will talk about their opinions all day, and more than likely, they'll say, I know somebody who's looking for someone that needs a job. And then they'll point you to it. And that's what happened with me. I emailed a bunch of professors. I went to some doors. I knocked, like show up in person, and I ended up getting a research job. And then from that, I just kept snowballing that into other research positions. And then eventually between junior and senior year, I took the entire year off and just did research at a plasma physics lab at UCLA. Because I had enough AP credits. I could have graduated in 3 years, but never shortchanged college. It's awesome. So I wanted to be in college for 4 years. So I took one of those years as kind of like a gap to just do research. And then that really helped me get into the PhD program there. Because they knew I could already do research. And that's what a PhD is. They don't really give a shit like what your grades are. I mean, they do to an extent. They have to because there's like minimum requirements. But the end product of a PhD is not, did you get an A on this test? It's, did you discover something new? Could you do research? And were you able to write it up and communicate it? And those are things that do correlate with great grades, great SAT scores, great whatever the fuck. But if you can show them ahead of time that you can already do those things as an undergraduate, you have a really, really good chance of getting in as a graduate student. So, yeah. Programming language, I used IDL. All my data analysis was in IDL, which is now antiquated because everyone's using Python. So if you want to do data analysis as a PhD, these days it's all Python. Yeah, I don't know what this question is. Someone submitted it though. Producers, primary consumers, secondary consumers, tertiary. Yeah, I don't know what all this stuff is. Okay, cool. Sometimes people submit questions to me and I don't know if they're actually questions, but it's okay. All right, so I'm gonna clear number 5. Wait, what the fuck? Oh, you submitted more things to me. Oh, here we go. Thank you, dog. Never mind. I was about to skip you, but then I saw you gave some context. Thank you. Hallman says, I graduate in May and have pretty decent research experience. I'm trying to do AMO. You did plasma? Yep, I did plasma. AMO's great. I would say in order to get into AMO, yeah, letters of recommendation help for sure, especially if you have other AMO labs you've worked with. And do well in the physics GRE. I think that's kind of that's the grade thing you have to do well in, and have like above like a 3.0 GPA, I hope. There are some minimum requirements you have to have. Okay. Okay, so here we go. I mean, let me try and understand this. A permanent ice glacier is in New Zealand. Due to the temperature changes, the glacier expands for 6 months and recedes for 6 months. The changing distance of a point on the front end of the glacier to a car park can be modeled by a sine function. Oh, okay, cool. Wait, so I don't think this has anything to do with this, right? Can we get rid of this? Okay, cool. Yeah, exactly. Okay. Cool. It's per month, right? So I think we're gonna use T's and months, right? It expands for 6 months and it recedes for 6 months. Sure. Okay. So, and they said a sine function. I agree with that. So expanding for 6 months would be the first half, right? So this would be 6 months. And then it recedes for 6 months. Oh, wait, but then it expands again, right? Wait. Yeah, but then is it negative? Oh, I see what's happening. Sorry. This is like this. Sorry, this is the. I got you. Sorry. differentiate twice. Yeah, but wait a minute. It expands and then it recedes and then it expands. Oh, okay. So, I see. Sorry, I'm like losing my head today. Well, we have been streaming for 3 hours, so. Okay, sorry, this is what we want, right? Right? Okay. So from here to here, this is 6 months, right? So actually, I want to model this maybe as like a negative cosine function, right? Does that sound better to us? Can I do it as a cosine function? It just said any sort of sinusoidal, right? Well, they really want a sine function. Oh, fine. Okay. But anyways, okay, so amplitude is equal to 280 minus 270 all over 2. Right? So A is equal to 5. That's the amplitude. The midpoint is 275. I don't know how we say that. We say like B. Let me write what it is. So it's y is equal to A sine BT plus C, or sorry, BT plus C plus D. The offset is always the midpoint of this, because here's what happens. It oscillates from 270 up to 280. So the midpoint of it has to be 275. This is a jump of 5. This is a jump of 5. So we have y is equal to 5 sine, and then b here is equal to 2 pi over the period. The period is how much time it takes for it to do a complete oscillation. And so that's 12 months. So b is equal to pi over 6. 2 pi over 12 is pi over 6. So I have pi over 6 t. And then I need a phase shift. Okay. So it starts at 0 here. So wait, this is 6 months, right? So then this is 9 months. Oh, okay, wait. No, I just have to do plus 3 months. Right? Because really it's starting back here. Right? And that's a quarter of a period. Quarter of 12 months is 3 months. And so that's plus 3. Right? I think it's right. Yeah. And then this is plus 275. Cool. Okay. Absolute values of the acceleration are greater than this. The geologist will spend a total between 7 and 8 months at the campsite each year. That's cool. Yeah, the first max are min. So the first max is, well, sine is a 0, right?
Nice.
What's up, Johnny? Oh, we got another follow. Thank you. We're almost up to 1900. That's cool. Thank you, Zen Daddy. Thanks for the shout out too, High Potential. Okay, so this is this. So the acceleration is equal to d squared y dt. Which is going to pull out this. So sine's going to go to cosine, cosine's going to negative sine, and then it's going to each time pull out a pi over 6. So you're going to get negative 5 pi squared over 36 sine of pi over 6 t plus 3, right? And then I don't care about the 275, right? That goes away. Correct? I think that's okay. Okay, so now... What's up, Johnny? Oh, Johnny Sins. Oh, you have a porn star as your name. Oh, I get it. I was like, Johnny Sins? Johnny Sins what? Oh, that's cute. Okay. So it's negative sign, but then it's back. Okay, so it's like this. Wait, fuck. You can use the... There's a website down there to ask questions. Okay, let's put... This is where I'm going to use a calculator to do this. Because I think it's cool to do it this way. T plus 3 stays the same? I think so. Right? Because, for instance, if you have y is equal to sine of... I don't know, let's just say like 3x plus 4 dy dx is equal to cosine of 3x plus 4 times the derivative of what's inside, which is just 3. And then d squared y dx would be equal to negative sine 3x plus 4 times 3 times derivative of what's inside, so times another 3, so that's like 3 squared. Can anyone prove the Riemann hypothesis that all non-trivial zeros of the zeta function lie on the line? I feel like I've heard this. Is this like copy pasta, dude? This is great meme sauce. Zen Daddy says, I just took a test for Calc 2 and I'm just wondering if I got the right answer. I asked ChatGPT, but it doesn't explain the best for me. No, totally. So Zen Daddy, if you want to submit your Calc 2 question, can you put the screenshot in there, please? There's a website. It's a very easy website for you to submit questions. Yeah, so I don't think the plus 3 does anything. So here, let's just put this in. So this is negative 5 pi squared, right? Divided by 36. And then this is times the sine of pi over 6 times x plus 3, right? And let's trace it. It's probably going to get mad at me. Because it's small. Yeah, because it's a very low period, I guess. Wait, that's negative. That should be pretty close to... Okay, window. All right, minimum time, 0. Maximum time... Let's say a year, right? 12 months, right? Because they said out of the year, right? And then the minimum y there shouldn't be too much. It's like negative 2 to 2, no? It's just a fucking straight line? That doesn't make any sense. Wait. Pi over 6. Did we not do something right here? Oh, because I was in degree mode. Oh, fucking fuck. Okay, there we go. Oh my god. Goddamn degree mode. Okay. And they want to know the value of the acceleration. Oh, you know, this is actually a very cool number they give us here. I'm going to show you real quick why this is like a nice... I actually don't even really need the calculator here. Because 5 pi squared over 72... This is when this whole thing here is equal to the square root of 3 over 2. What's up, Jack? Wait, is it Jack? Wait, Jack from Alabama, Jack? You know which Jack I'm talking about? Like, we used to play Warzone together? Jack, the panic one? Jack attack? Nice, Zen Daddy, I see it. Okay, so this is asking when this thing is square root of 3 over 2. And so this is very cool. So square root of 3 over 2 for sine, that occurs at 60 degrees, right? And so it's greater between 60 degrees to 120 degrees. And then from 240 degrees to 300 degrees. Yeah? So, yeah, this is such a cool question, actually. Yeah, I like this. So, it's from here to here. And then it's from here to here, right? So, this is 120 degrees. No, sorry. This is 60 degrees total. This is 60 degrees total. So 120 degrees out of the 360 degrees, which is the total year. So that's a third of the month. The geologist will spend a total between 7 and 8 months at the campsite each calendar year. Oh, okay, yeah. I agree with that. I think it's between 9 months, really. Yeah, a third of the year. No, a third of the year is 8 months. So it's 4 months. So yeah. Yeah, I think this is cool. I think this, yes, reasonable. Nice. Cool question. I like that one. That's really dope. We didn't even need the calculator to graph that. You could have just realized that when you find out your acceleration term, that this thing that comes out, the omega squared, is found literally right here. That's what this is. Sorry, this is this. But it's like half of it, so you need this whole thing to be square root of 3 over 2. Wow, that's very cool. And you need sine to be greater. Oh, wow. Cool. Cool question. Nice. All right. Zen Daddy, Yadavir. Let me see if I can help out Yadavir real quick. I have 9 minutes. Was that your question? Was that your question, Christophorus? Was that yours? Oh no. Oh, it was cool though. Okay, and then I see, just to show you that I have it. This one might take a little bit more time than Daddy. Oh man. Oh wow. Yeah, this is a pressure question. I know this one is. Do you want to come by tomorrow, Zen Daddy? Because I have done this question. I know exactly what this question is. This is like dy, and then this is like dx. So then what you get is like, I think pressure is equal to like, oh, fuck, what is it? Pressure equals force over area. So force is equal to pressure dA. And then pressure is equal to, so then force is equal to pressure dx dy. And then you need to integrate this, because then, okay, I remember what this is. This pressure, this ends up being like rho g y. And then you have dx dy. And then you have to integrate from minus x to x, right? Like from here to here. And then you have to integrate dy from 0 to 6. Just real quickly, this is kind of what it is. I'm pretty sure this is how this works. And then this, yeah, this y function, yeah. It's something like this. I've seen it. I literally did this question, I think, a couple weeks ago. But yeah, the same website you went to, by the way, to do this, to submit this, there's a schedule here. If you want to come by the stream tomorrow, I'm going to be streaming at 4 o'clock. I can help out. Otherwise, yeah, Wednesday as well. Zach's doing something on... Tomorrow, Zach's doing math on a topic where he talks about like a specific math topic. Wednesday, he does homework help. But this is a very cool question. I like this one. I would love to do this one with you. Just come by tomorrow and bug me. Be like, hey, I asked you yesterday, and I'll move you to the top. I'm on a little bit of a time restriction today. Also, we lost our music. Where'd the music go? Come on. Here we go. So I don't know what time zone you're in, Zen Daddy. If you're here around this time tomorrow, I will be on. Because I start streaming at 4 o'clock tomorrow. Yeah. I don't know what time zone you're in, though. That's me, my friend. Okay. Let me help out Yadavir real quick if I can do this one. This looks like a series, and then we're re-indexing too here. Oh, super toughy. Yeah, you're very welcome. Thanks for finding us, dude. Okay. Sorry, what is this? Is this T sub R? Okay. Integral, the summation R to N of T sub R is equal to this. So, So summation N equals 2 to infinity is equal to T of 1. No. Sorry, is equal to the summation N equals 1 to infinity minus the first term, right? Do we agree with this? Right, if you want to re-index up, or I guess I could do a substitution thing. I'm gonna keep this for now. I think that might work. Okay. I think let U equal. Is it okay. Let N equal U minus 1, right? So then the summation of N equal, let R equal U minus 1. So from R equals 1 to N of T sub R. Oh, but no, I don't want to change this. No. We don't want to change that. Don't want to change that. Let's not do that. Okay. Oh, okay. So... Oh, this is easy then. No. Right? So... 1 divided by it... Is this true? Let's think about this. So 1 plus 1/2 plus 1/3. Is that the same thing as 1 plus... It is, right? Yeah, okay. Okay. Oh, I think I got this then. So, this is equal to... 1 over n squared minus 1, right? And then if it starts from n equals 2 to infinity, that's equal to 1 over n squared minus 1. Oh, no. Minus 1 over 0. Uh-oh, that's fucked up. Oh, shit. No. Oh no. How are we gonna do this then? don't you use 2? Yeah. But, well, here's the thing. If you want the series to start at 2, you have to do the series starting at 1, subtracting from the first element. So in order for the series... This is it starting at 1, right? It's just 1 over what the regular series was. But then for it to start at 2, I need it to be the regular series minus it starting at 1. But this is ugly. Yeah, geometric series. Okay, I'm tempted to rewrite this out, right? I'm going to write this as 1 over n plus 1, n minus 1 maybe, right? Which, this is equal to a over n plus b over n plus 1 plus c over n minus 1, right? So, an plus a... Oh, wait. A n squared minus a plus b n squared minus bn plus cn squared plus cn, right? Has to equal 1. So, a plus b is equal to 0. No, a plus b plus c is equal to 0. Minus a minus b minus c is equal to 0. And then minus a is equal to 1. So a equals minus 1. So b plus c equals 1. B plus c equals 1 from these two. No? Yeah, isn't that the same shit? Oh, that doesn't really help me out, does it? Fuck. B plus c equals 1. Can we just set b and c to be whatever then? Right. Oh, you're so right. Wait. This is a factor on its own. Isn't this a quadratic, though? No, this is a quadratic. Oh, shit. Sorry. Wait, I thought I for sure could just split it out like this, though. Can I? Well, I agree it's equal to minus 1 over n. I don't know where you get the n over n squared minus 1, but let's pretend it is. Okay. That still breaks. Alright, I'm running out of time because, Yadavir, unfortunately, I have to go. Here, I just threw this in the chat real quick, just to see what it is. Yeah. Okay, here you go. This is apparently the solution. Partial sums. Oh, I see. Oh, this is cute. Yeah, no. They distributed this out, right? So in T sub n is S of n minus S of n minus 1. How does that work? Ugh. Okay, I really gotta go. Alright, cool. Good question out of here, but let me end up the stream.
That's dope.
Alright, thank you everyone for coming to Actual Education Office Hours. Appreciate all the questions. Had a really fun time with you guys. Our next stream is tomorrow. That'll be at 4 p.m. 4 p.m. Pacific, 5 p.m. Mountain, 6 p.m. Central, 7 p.m. Eastern. Come on by, get help with your math and science homework. We're here for you guys. Yes, cool question. Yeah, I'll go over it a little bit more next time. And also, Zendaddy, if you come by, I'll help you out. If you're watching us on Twitch, we're gonna go raid somebody, go say hi to somebody. There is so many people on right now. Eric. Oh, nice. Eric is doing tax season. He's doxing himself. Oh, that's kind of interesting. Sure. I like Eric. Let's go say hi to Eric. He's a cool guy. Okay. Cool. All right. We will see you tomorrow. Enjoy the start of your week. Hope you guys had a great vacation day today. Peace.